Hello there. Hi. Welcome here. Let me also join my Google Meet. My Google Meet. Hello.
Hello. How's it going? Can you hear me?
All right. We'll jump right into it. We'll not wait too much for this one because it might take, even though I cut it in two, so C# today and general coding practices and Unity and general Unity practices tomorrow, it still might take even 3 hours or more. I don't know. Yeah. So let's see. Streaming looks all right. I went and posted this live stream on Reddit and on some Discord servers because I thought that it will help other people as well. So yeah. Okay. On Reddit. Okay, so sound works. Yeah, so should I not use my mic? So if you have any questions or stuff like that, like you can write it here in the chat, and when there will be some moments of like we have some breaks or near the end, uh, yeah, we can also talk there. Like, but in order to make sure that the session goes as planned and that we have enough time for all the slides and all of the ideas and examples and so on. Like I just muted you, everyone. Yeah, I don't know. Unity warns me that I'm running administrator. Well, yeah, I mean, when you install it or there are some scripts, I don't know, don't remember. Yeah, I don't know what that's about. What's that about? I don't know. I mean, if you're on Windows and oh, I think you mean that it shows in console that you're running as administrator. Yeah, just don't worry about it. Yeah, let's wait maybe 2 more minutes, maximum 2 more minutes for more people to show up. Hello there. Okay, so I think we can start. Uh, yeah, 1 second now. I have to do some things. Hello, hello. All right, hello, Colin, and I think we can start now for real. Yeah. Good. Good. So, welcome to second week, third day. Today is a bit of a special meet, a special session today and tomorrow. In that today, like any programmer from any background with who programs in any language can attend this thing, and they will level up. Yeah, so we'll talk about a lot of things, and we'll talk we'll briefly go into the beginners realm in C sharp, and but most of the time, and near the end, mostly we'll mostly hang around the advanced user side, and what will you use in the following years or your whole programmer lifetime. So yeah, I'm kind of trying to hit many birds. Actually, two birds with the same stone. So beginners and advanced users. So at any given point of this stream, there will be someone that will feel that that certain part of video is boring, or it doesn't uh, appear as immediately useful. So yeah, just have to stick around and have some patience. Um, good. So we'll be talking about C sharp because that's what I know best, or at least, yeah, let's say, yeah, I still know C sharp best, although I went into Python a lot lately. And yeah, because of course C sharp also applies to Unity, and this is a game development course, so we are not losing focus. Good. So finally, something actually useful. Um, so fact, C sharp is almost Java, but with some extra legroom. So you have more space. uh, Here's another meme. So C sharp is just Microsoft Java. That's basically it. Uh, Good. Yeah, and I said like the prerequisites of this course are just you have to know some code. At least you should have uh, watched some basics. That would have taken you like an hour or so, but doesn't matter. Like even if you don't know anything, I'll try to bring you here, right, in this area of um, beginner programmer. Yeah, let's do this. So Unity uses C sharp because it's pretty versatile, and it allows you to organize your code into huge code bases, like also like Java does, and C, and other programming languages. Um, And also Microsoft, because Unity kind of got a lot of help from Microsoft, if I remember correctly. And yeah, it's there are a lot of incentives there to use it. Yeah, like I don't regret learning C sharp. So I could have easily learned some other language, but because I was into gaming and Unity used C sharp, I just learned this one. And yeah, like I'm like 90% satisfied with C sharp, right? And it gave me like everything that I needed, and you can be really creative and you can be really bold. You can create very complex things, and it's very nice. And you basically write the thing once and then reuse it, and so on and so forth, which is also like in most languages that's true. Um, yeah, we'll try to cover basic concepts needed in game development, but as I said, even if you're not a game developer, this is will be very useful for you. Um, yeah, and if you want to go hardcore on coding, like on the syntax and like going into threads and uh, classes and a lot of inheritance stuff and all of that, really deep into it, you go on this link. I don't know, I don't remember. Okay, this is not my C sharp. So let me just open it here briefly on my other account.
Hey, welcome to Draft Academy.
So I don't remember exactly what this was about, but I know that when I created the slides, basically it was a very good beginner full C sharp tutorial class. And I really recommend this guy. I went through the video and like he goes into like all of the nitty-gritty stuff, right? Like I said, the methods and functions and everything. And we'll go through them briefly, but we'll mostly be talking about coding patterns. And I know it's kind of backwards because you'd first learn the code and then you learn what are the best practices for that code. But we'll try to think about it more abstractly, in the sense that we'll talk about concepts, not necessarily about C sharp, right? So we'll talk about how things should be. And that applies to any programming language, and it will really help you um, to think of it that way. And I don't know if it's the best approach or not, but we're doing half like it's half knowledge, half experiment. So yeah, good. So this is the guy. I'll send this link here. Just save it for later if you want to go to become an expert. Good. Yeah, we'll be diving in deeper into the C sharp realm while we'll do the practice sessions a bit next week, and the week after we'll go even deeper when I will be coding. We'll see what I'll actually do. There are a lot of because this was meant to be like in real life, like an in-person course, when there was in week 4 3 days where I would go and like be in the same classroom as you, and we'll be talking about the practice project that you would have been working on. So but now basically probably I will create I will basically do live coding of a small project from start to finish. Good. Yeah, so we'll be starting with the desired result and we'll work backgrounds from there. So backwards from there. So we'll be stating like, okay, we need this thing, and what do we need for this thing, and we'll go backwards, like from the result towards the code. We'll not just start coding and figuring out on the fly. Although you can do that as well, and that's the easier thing to do actually. It's easy to just jump into code and just hang around, bang your head around some walls. Then you see like, okay, that's not good. Let's delete that code, create again, and so on. But most of the time, I like to just keep this top-down approach where you first go from the result towards towards the actual writing of the code. And if you think about it, writing the code should actually be just like translating. So when you translate language, most of the time you don't think that much. It's automatic, right? There are some like 10% thinking maybe, like you have to convert some syntax, some expressions. But most of the time it's automatic. So converting the idea from your head in coding should be automatic, right? Because you should already know what you want. Good. So that's why you have designs, sketches, you have mind mapping tools, or just a pen and paper, right? Good. Okay. And we just go straight into C#, just a high level overview of every feature, every not every feature, but what are the most important features that we'll be using in game development, but also like in general, like it overlaps 90% with any like if you're creating websites in C# or other stuff like that. And if you're here from previous weeks, we've done some coding just so I can show you some stuff, right? And it wasn't about the code, but about the results. So because we were learning about the animation, sounds, physics, and all of that, right? And we had to write some code at some point. Good, but now we're really talking about it. So variables are the most fundamental concept in any programming language. So they are like stuff that holds a value, right? So like in maths, so most of you, I hope you have done maths in school. So you were just searching for this x always and didn't know what the value is. And yeah, that's like a variable, right? And in coding, it's more versatile than that. Like you have you declare a variable. You can have like a 50-character variable if you want. And I've done that at some point because you have a variable whose function is so complex, or at least has so many functions, that you have to like write very long name for it. Otherwise, you have to write a comment. And usually you shouldn't write comments unless you really need to. You should like tell a story. You should your variable names should say what they do. So there shouldn't be a need to explain what the variable does. So okay, on C# you have like integers. So for example, player health, and this is how you assign a value to it. So when you write equals, this is an instruction. It's not an assertion. It's not it's not a question. It's not um, it's not like in math where this is like the truth. It's just an instruction, and the instruction is just imagine there's also a less than symbol here in a way where it would signify that, okay, put the value 100 into this variable, right? That's what it does. And yeah, you can have like player health, annual count. Float means decimal numbers with a decimal point, like 7.5. And yeah, in Unity, you have to put this F here. I mean, in C#, you have to put this F here because there are two types of floating point numbers. There are float and double. Literally, you have to write the word double. And what that means is you can have double precision, which means you can. So on float, you can have, I think, something like 7 decimals until you lose precision. It's a bit more complicated than that, but just as a general rule, you can have like either 5 or 7 decimals of precision. But with the double, you can have double that, or maybe a bit more than that. Yeah, good. So you can have like 5.555 10 times whatever in a float, but by having 5 or 7, I don't remember, decimals of precision, what that means is that you can represent all of the numbers, all of the possible numbers, right? So 7.1235 or 5, 4, 3, 2, 1, whatever, right? But then if you go to the next decimal, at some point you would lose precision. You would not be able to represent all of the possible numbers, right? And that's why in finance there's even in C#, there's even a data type which is called decimal. So that one I think has, I don't know, double the precision of the double. And it's not here, but just imagine like instead of float, you would write double, right? And I mean, let's just do this, right? Just have it there. And we didn't talk about strings too much because now it's like the official lesson, official class when we will be talking about strings. But it's called string because it's like a string of characters, right? So just imagine that you replace string with text, right? So text player name. So this is your text, and the way you declare a text, you put it in double quotes, and you can write anything there, right? Yeah, so that's your text. So when you want to store text, and it can be pretty large. So it can be, let's say, arbitrarily large, and of course there's a limit for that. I don't remember what limit it is, but you can have like megabytes of text in a variable if you want, if you really want. Yeah. Let's where are you, man? Okay. Yeah, so you have a string, you have floats, integers, and when you say public means that whatever the scope, so imagine that you have these curly braces, like these things, and when you can only declare variables as public or private in the classes body here. And we'll talk about classes later. So we have like, and what that means is that if you have another class and you create an instance of this thing, I mean, let's call it, you can access this X if it's public, right? You can access it if it's public, but if it's not, or I mean, let's say like 1, that's what public means, that if you're in another class, right, and you have an instance of this class, an instance means you write new this class and it basically allocates some memory in your RAM or whatever, and then you have, this is a handle for that memory, and you do w.x equals 2. So you're basically changing the value of x for this instance, right? But if you have it like private, which is the default, you cannot do it because x is inaccessible due to its protection level. And it can also have protected, which means it's the same thing as private. We will talk about it later. So that's what it does, right? That's what public and private does, and we'll talk about that later as well. Just in case you like want to really know what it means now. Good. Also I wanted to show the float. So this is a float. Let's say like this can have like 5 decimal points or 7. Let's say I think it's 7. Precision 7 decimal, yeah, digits. 7. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Yeah, 7 digits. And double can have many more. I don't remember how many. It's not like, I don't think it's double. I think it's more than that, but I don't remember. So yeah, we can write like stuff like this, something like this. I don't know. And also like the numbers themselves can be bigger, right? I mean, since we are at it, let's just do it, right? Float range goes from this number to this number, which is big. Like this 38 means 38 zeros, and in this case, it's like multiplying 3.4 whatever with 10 to the power of 38, which is pretty big. So you can have big numbers, but you lose the precision. So you, at some point, you might even jump from, like, say, just assuming 1,075,000 to 1,076,000. Like you cannot have 1,075,500 or something like that. I just reduced the example. Of course, you can have that, but imagine like 1 billion and whatever. So at some point so the more you come closer to zero, the finer adjustment you can have, because those are the numbers you use the most. And the further you go towards negative infinity and positive infinity, the bigger the increments go. But you still have plenty of space, like I said. So probably a couple millions or billions, I don't remember, you can use with full precision. And double is just multiply this number 1 point whatever with 10 to the power of 300. So 300 zeros. So yeah, that's you can have a lot of precision, and you also can have, and decimal it's something, I mean, we won't go too much into it, but basically what decimal does, it does something very similar than to the double. But you can have like a lot of decimals. I know, not exactly like this, but yeah, and you can have like a double can be something like this, right? And float can be something like this. So not only to the right side, you can also have it to the left side, right? And double can be something like this. These are not exact numbers; they are just relative to each other. They kind of make sense in the sense that this can have much more than this one, and this can have much more than this one. So decimal can have much more than this one, but in terms of decimals. Because I think it occupies the same amount of space as a double in memory. So this is 4 bytes, and this is 8 bytes, and this is, I think, still 8 bytes. And the way it does that is it sacrifices bigger numbers in favor of more precision to the right of the decimal point. And this decimal thing is used in finance apps a lot, because you don't want, you have a lot of commissions, 0.00 whatever, and you want to sum those up, and you want to a very high precision, right? You want a very high precision. Yeah, I don't remember how you Okay, yeah, you have to put it like this. It's kind of just saying, okay, this number interpret it as a float, and you put an F here. This number interpret it as a double, and you put it like this. And this one you interpret it as a decimal, and then you can do like var, so that you don't need to specify also the. So var is a universal keyword. You can use it to specify any type, as long as it's obvious from the right side what type it is. Good. So, and also strings, like you saw them there. So you have strings, hello, right? And you can do something like this, hello.x. So you can add up the string with a number, and you'll basically see hello and something close to this number. You won't see exactly this number. And of course, you can do like var a equals whatever. And then you can do like var b equals something. And you can then have c equals a plus b. So you basically add up this string with this string, and I put here a space so that you have a space between them. So a plus b. So you, by adding strings like this, you basically concatenate them. And you can also have it like this, right? Good. Assigning values to variables. So yeah, think of the equal sign as this sign. Basically compute what's on the right side and store it to the left side. Because, for example, here, the C# runtime has to first compute what this means, like to create a final value for it. So it takes this, it adds whatever this variable has in it to it, and then it adds this thing to it, and then it creates it creates like this. So this happens in memory. So it creates this and then stores this string somewhere in memory and then assigns it to this variable, right? This is just behind the scenes stuff. Yeah, so you can have Boolean values. So a Boolean value can be only true or false. Like, let's say is game over equals false, and at some point you press a button and let's say that's your whole game. You press a button and the game is over. And you set this to true, and there's someone that checks this bool once per second, and if it's true, some fireworks, pop off or something like that. Or whether the player has a key or not, so they can open a door, right? And just ignore this bulb. This is from Visual Studio. It has this thing here. Good. And these things are for from Unity. So I put the icon here. So you have the game object, which is a player. I mean, can be a player object. You have the transform, which can be the player's transform, through which you can move, scale, and whatever. And like this is an example for Unity. So you have like int, which comes from integer. Total damage equals player attack plus weapon damage, so that it's a simplistic calculation. So your base attack is 10, and you have a weapon that has like a 2 attack, and then you have a 12 attack, right? And your total damage is 12, and then you use this for something. Or you can calculate the distance, which is a floating point, because you can have it like 10.7, whatever, right? And this is a Unity function. You like get the vector3 class without creating an instance for it, and we'll talk about that later. But basically, you're not creating a vector itself, but you're calling a function from the vector class, which is a static function, so that you don't need an instance of a vector. Like, you don't need to create like new vector and give it the value for x, y, z, and then call this distance, because this is a function that doesn't need any state. It's a stateless function. So the reason for that is that it's pretty nice to read it this way, because the distance is the distance for vectors in a way. So you take 2 points, so the player transform dot position and target dot position, and you basically ask what's the distance between these 3 vectors. In this case, the vector being just a list of 3 numbers, basically. Unity uses it for positions, for velocity, somehow, let's say, for rotation, for scale, because you have the X, Y, and Z components, right? And they are just numbers, and you can give them any semantics you want. In this case, you have vector 3 for position and a vector 3 for player's position and for target's position, and you get the distance here. And it's like in units, or it's a convention that we say they are meters in Unity. Good, yeah. So this is like the way you assign the calculation of this thing to this thing here. Yeah, and what people do with all their time, they save when they using yeah, I completely messed this up. You just look at it. But basically, instead of writing this game object transform and yeah, these are the only examples at this point. You just write a var, right? Because it's easier, and in most cases, it's obvious what what type the value has, right? Var game object equals game object, and like I have access to this thing because it comes from the parent class. So this is actually the inheritance operator. So basically this class doesn't only have this function, but it also has everything from this class. Everything here. So where are you? Mono behavior. Somewhere like this. But yeah, anyway, like yeah, I hate it that it shows it this way. But anyway, yeah, these are functions, and let's see, can I double click it? No, I cannot. Yeah, so whatever this mono behavior has, oh, okay, now I can see it. That's strange. So you see this mono behavior has lots of things there. Come on, man, you just showed it to me. Anyway, it has a lot of things here, like cancel, invoke, start coroutine, and lots of other properties. And we are basically inheriting from it. And it's as if we have all of those things here, right? And including this game object, right? And like the most canonical way of referring to this game object would have been like this dot game object. That's like the most explicit way of doing it, but it's redundant to do it this way, unless like you have a var, I don't know, 1, and in that case you have to qualify it with this prefix, right? Because there are 2 things. So first you create a variable here, which is an integer, but the base class also has this game object. Yeah, it's here, which is like the game object type. Okay, and that's why usually like for classes, so for not primitives, which are bool, floats, strings, integers, right? So for non-primitive types, like game object transforms, or things that have many other things in them, or yeah, we'll talk about this later. It's generally better you just write var, right? And that's why I put this meme here. So what people do with all their time, with all the time they save by using var instead of uint, and this is actually uint is another type, but we won't be using it. Basically, uint is unsigned int, and it means that you cannot have negative numbers. which that allows you to have, I think, double the amount of numbers or something like that. Yeah. So because now the maximum, so uint max value is this 429 whatever 4 billions. 4 billions, right? Or millions? Okay. Yeah, 4 billions. But no. But integers max value is 2 billions. You see? Because they are occupying 4 bytes in memory, and in order to occupy the same space, you have to trade off some. So integer can go from minus 214 whatever, like mean. If you do like mean value, you go from minus whatever to plus whatever, but uint goes from 0 to basically double that, right? Just chooses the same, the whole space. So that's what uint comes from. Yeah. Yeah, so variables are like those in math. And a function can alter some properties permanently. Since on a computer you have access to many resources like disk, so storage, network, and RAM, and yeah, like transaction records in a database, and lots of other things. And that's why like a function is it's like a mathematical function, but a mathematical function, it doesn't have any state, at least in classical maths that I know of. So a function doesn't have a state. A function is what they call in programming a function is a functional thing. So in programming, functional programming lies around this concept that a function cannot access anything from outside world other than what you give it in the parameters list. And this is the parameters list, right? So you have like, so a function, I think they are also called pure functions, but that terminology might not be perfect at this point. So this is like the simplest function, not the simplest, but one of the simplest. And it's called add. And let's use which is what is called Pascal case. This is Pascal case, which means each word has an uppercase. And this is called camel case, and it's used in Java and I think JavaScript and a lot of other languages. And this is like Pascal case. So first letter, uppercase, and so on. Good. This is on C#, right? C#'s convention. So this is a simple function. It adds 2 numbers. And it's a function that doesn't access the class's state. So the state is, for example, so this is like this is how you to write a property in C#, and we'll talk about those later. So basically last error, and let's say like you have like on collision enter or whatever, and you expose this last error publicly, right? And you like put this thing here, null. Yeah, and null is a value which means nothing. So you have no error. And you can also do it like this if you want, like an empty string. Like low resources or whatever, like you have a last error. And if this function would access this last error, so if last error is not null, we just don't worry about this. Doesn't really make sense, but just for the logic of it, so this we have now, this function is a stateful function, or at least stateful, but it depends on the class's state. And yeah, so now it checks whether the class had an error, and there was an error. It throws an exception, and what this means is that it interrupts the execution of the program, and it shows you this error. So when it comes here, it won't execute this thing. So it's like it stops it. It's like says, okay, hey, stop everything. Just see this exception here. This is very important, and this thing is very important for, I don't know, finance applications or like rocket launches and all of that. Like you want to stop the execution if something goes really bad. You don't want to enter a state where you'd, I don't know, lose a lot of money or whatever. You delete some records, you delete in your database, or you'd like change a number in the database that represents credits the funds of one of your clients, and it goes from 1 billion to 1 million, right, or something like that. You want to throw exceptions when you detect something that's like an anomaly. And of course, you have to be proactive about it, and we won't talk about them here because yeah, like you want to start with some optimism, right? Like there will be no errors, but of course there are many. Good. So, and in this case, it's not functional programming anymore, right? It's regular programming. Good, but now it's like functional programming because everything that this function needs, it gets in the parameter list, and that's why you can also do it like this. And static means that this function surely doesn't access any of the state of this class. And you remember that vector3.distance, and that's what this function does. It's the static function, public static function distance. And you see, it just is. This is yeah, I don't know. It just it hides it. But basically, that was the formula for the distance between two positions, 2 points, and basically here, because you've made that static, you can just without creating an instance of this class, you can access it directly, right? Yeah, you can do something here, 1 2, right? And just you can and basically now you will print to the console, to Unity's console, this 3. You'll print the number 3. And of course, like, I mean, somebody has to call this function, but don't worry about it now. But I wanted to emphasize this thing, like when you make a function static, you can access it like this, right? If it's not static, then you have to create an instance of that class. Right? And of course, now if you made it an instance function, and that's what it's even called, and in an instance class, you can access this last error, whatever, right? Last error. Yeah. And again, if you put it like, if you turn it static again, you cannot access it because an object reference is required, right? You have you're not inside the object reference, but you're inside the class itself. And that's how you do stuff like, and a static class is just like syntactic sugar or something. It's just a hint that this class will never be instantiated. And actually, I think you can not even instantiate it. my math. So like if you want to create one second, I'll be back. Okay. So yeah, like you remember there's this from Unity mathf apps, and you can basically turn a number into its absolute value, right? So you can turn a number into its absolute value like this with the mathf apps. And what this does, what this is just it's just a static class, public static apps. Okay, let's go back. And maths, where are you? This is just a static class like this. So you can create your own if you want, like you can have my math, public static int, I don't know. Let's assume we want to create a new way of adding numbers up. And I don't know, let's say that so your program doesn't allow the 666 sum to happen anywhere, right? Something like this. System dot exception. Cannot possible, right? That's your public. Yeah, so you cannot like add two numbers that add up to 66. So deal with it, right? That's your math, new math, right? But the more like I don't know, a more realistic example. But you get the idea, like you can have a lot of parameters here, right? And you can do a lot of complicated things here, and you can return an instance of this class, like you do like new whatever and whatever, right? Or you can return like an object, which an object is a generic way of like everything is an object. So an integer is an object, a string is an object, this class is an object. It's like the ancestor of every possible class. And yeah, in some advanced cases you would do this where like at some point you return 7, but in some cases you return a string, and in some cases you return this thing like on like if whatever you return this thing, right? And we'll talk about this later, don't worry. Good. So this was like very in-depth introduction for functions. Good. So yeah, this is the function code within the function, and it has some parameters, and it's public or not. If you don't specify anything, it's private. Void is what it returns, and void means nothing, and function can return nothing. Yeah, because for example, maybe it's a function for printing something on the console. So that printing is done at a lower level in Unity. So you don't really return something to the function in that case. And parameters, like I said, you can have a lot of parameters. A function without parameters, like display message, hello from a function. Okay. Calculate damage. So you have like, you can have this in your math class, that math utility class. where you send it the attack. Let's say like a player hits another player, and you know the attack of the player and the defense of the other player, and you just call this function. And I mean, the most basic thing you can do, you just like attack is 100 and defense is 10, then you subtract 10 from 100 and like the damage is 90, right? Very simple, but you have like kind of very complex thing there. Function with parameters with Unity stuff in it. Yeah, like I said, the update function is called each frame. So let's say like 60 times per second as an example. And this is the function with the parameters where you will move the player actually. And you specify what speed to move the player at, basically meters per second, and the direction. And the direction is a unit vector. So basically it's an actual vector. So its length is 1, and it can point in any direction on the unit sphere, right? So imagine a sphere of radius of 1 meter, and the origin of this vector sits in the center of the sphere, so inside it. And the other, like basically the arrow part of the vector basically can travel on any point on the surface of the sphere, right? That's your unit vector. And that's the direction. That's how you model direction. That's how you represent directions with a vector, right? Because it's just 3 numbers, right? A position is 3 numbers in 3D space at least. A vector is the 3 numbers, and the cool part about vectors is that you have the direction, but also the length of the vector also can represent some information, like the intensity of the force or the force of that vector. And I'm sure you're familiar with forces from physics in school, and it's the same thing. And basically you could just multiply speed with direction, right? And you get a vector that's whose length is larger than 1, right? And you could have just had like vector 3 amount, or even a vector or delta or whatever you want to call it. But here for simplicity, I'm passing 2 parameters, right? So player object that transform dot translate. Translate means to move it basically. So in this direction, with this speed, and this amount per frame, basically. And if you remember from last time, because when you call this each frame, right, you want to be frame rate independent. So whether you call this 2 times per second or 100 times per second, you still want to move by the same amount per second, like your final effect. You want it to be independent of how often do you call this function, right? You don't want, like, if you call it 2 times, to move twice as much. And yeah, so because you have games like run at 30 FPS or 20 FPS, you have games that run at, I don't know, 240 FPS, and that's why you use this thing, which gives you the time since the last frame, right? And if the time since the last frame is 1 second, then this will be 1. And then you would move the way you'd expect, like direction and speed. So like meters per second. So you would, if speed is 7, you would move 7 meters per second if this was 1. And again, 1 would mean like 1 second since the last frame. So you're like running one, in this case, you'd run, like your game is probably running at 1 frames per second, right? So it's very, very slow. Good, that's it for that part. So if you know what variables and functions are, you already know what classes are. The boxes, we're organizing them in. So class has variables and functions. So I sometimes just, when I learn a new word or a new concept, and I see the word that represents that concept, I just immediately assume that it's complex and complicated. I don't know if that's everyone or just me, but just try to understand the concept behind it and not the words. And of course, just try to memorize the words because it's good to know them as well. But they are just that. So classes are boxes. Yeah, they are boxes of functions and variables. That's what they are. And they are more than that. They're like a template. They are like prefabs when we've talked about prefabs. They are like templates or blueprints, whatever you want to call them. They are a recipe for creating an instance in memory, right? And they can specify the variable default values and so on. Yeah, very good example, an enemy. So you have an enemy and you specified, like the default syntax is public class enemy. You can have like non-public classes, but generally you, like 99% of the time, you'd write public class, whatever, like enemy. And you see it has no parent class. So it's like, there's no parent class. It's it's like the most base class, right? It's the root class of everyone that, like, maybe you have boss enemy, right? Which inherits from this class. But yeah, it doesn't inherit from anything. And I mean, behind the scenes, it inherits from the object class, right? So this thing, if you have like, so this is a class, it doesn't inherit from any class, but behind the scenes, C# does this, right? So this is what happens behind the scenes, and this is what happens, like, not behind, in front of your eyes, because it's redundant to write it like this. So basically, the object or class is the base class of everything. Good, and it has a health, which is an integer, and I mean, you can have it as a float, which is from 0 to 1 or 0 to 100 or whatever, or and then you have a float, which is like meters per second, and then you have a function which you call it. For example, let's say you have a button or a joystick, or let's say a button, and on you, if you remember that there was, like, in the inspector, you can select the on click event, right? And when you press the button, you basically can attach, I mean, you have to inherit from mono behavior in order to, like, turn this into a script that can be attached to a game object. Let's discard this thing here. Okay. Good. So we have a 2D collision sound, whatever. Okay. I don't remember where it was, but yeah, in order to, let's create just an empty object. In order to attach, like we've attached this here, you have to inherit from mono behavior. So basically, the base class of your object of your class should be mono behavior, so you can attach it to actual objects. And in this case, you'd here you'll not be able to attach it. So it's more like an abstract piece of data that lies in memory, and you have to display it in some other way or access its property in another way. But let's say, like, it had some, it inherited from mono behavior, and it had this no, right? And you should see it here. Public void move. Okay, yeah, because it's a function, you don't see it. button. And you have this thing here, and of course it's not the only way of using it, and it's not even the most used way of using it. It's not the most popular way of using it. So you get this object on which we attach this component, and we go here and on click, we drag the object here, and then we go to our, see each you can see each component and then each function or property of each component. And then you have move, right? And then when you play the game and when you press the button, it will call this function. It doesn't do anything. It doesn't do anything, but it's called, trust me. Okay, oops, not like that, too much. We went, okay, this is it. Good, and that's functions for you. So it's a function that doesn't take any parameter and doesn't return anything because it does something with things that it already know, like speed, move towards player. And yeah, it's you would need to get a reference to the player manager and see where the player is and so on and so forth or something like that. But this is just like a skeleton, you know, it's a frame of a class, just so you can get the idea. Yeah, so classes are like blueprints or properties, prototypes. Yeah, like you aren't creating the thing, but merely define what the thing should be like. So just like from a house blueprint, you can create many houses, right? So you can create a lot of instances, right? And of course, I mean, can create a lot of. You cannot have a number as a function name, right? You can create many of them, so you can create millions, right? With a for loop, which is easier to do. And I mean, of course, you can reference the class itself from here. And if you're an absolute beginner, it's probably a bit mind-bending how you can reference it. But it works. Just try to not think about it too much. I just learned that in the recent years. So there are some concepts that the more you think about them, the more confusing they are. So you just try to go the other way and like go through the intuition way. And just when you see it here, you just like you see, oh, you're creating a new instance of the class itself, and that sounds weird, but let's just go with it. Let's see how it works, right? That you'll have a much easier time just thinking that way. So some things you can process logically, but some things just be it as it is, let it as it is, let it go, and think of them intuitively if you can. If not, just use them, and you'll build the intuition. Yeah. No, I think this is the same. Oh no, it's the player is different. So the player has a maximum health, and yeah, the player can have, I think, well, let's say 100 health. And when you create the player, this is the constructor, and we haven't talked about it. So the constructor is a special kind of function, and yeah, basically the constructor. Let's see, do we have this thing here? I think we. Where are you, man? I think we have even the code here. No? Yeah, we don't have that thing here. But anyway, let's go to. So the constructor. I mean, I don't know. Let's create a script. Just class, new class, new class, and it creates a constructor for us. So this is the class, and of course you'd put it into a namespace. Yeah, I have to. these are just some shortcuts. So you can select in Visual Studio these things, and with Option or Alt on Windows, you can move it with your arrows. So you have a new class, right? And your new class is empty, it doesn't have any members. That's what they're called, members. So a variable is a member, a function is a member, everything is a member. And when you create a new class, you can specify a constructor for it. And the constructor is a function which doesn't return anything explicitly, so you don't have to write void or like integer or whatever, because the constructor returns an instance of the class, right? Let's create another class just so you can see it easily. So the class, whatever. You can do like new class. Okay. And so basically create a new class and we assign it to X. But I mean, you don't need this in this case because it's given to you by default, the constructor. But let's say you want to assign this variable which is not public, or if it's public, you don't want to do like that, to write that and then x.x equals 1 or whatever. You want to pass it here like function, right? You do like int x, and then you do this dot x equals x. And then construct the class like this, new class 2, and it will basically call this function, which is a special function, which is a constructor. It takes this parameter x and it assigns it to this x here, and that's why we have to call to write x, because if we don't write it, then it assumes, okay, where is x, and it takes it to the from the closest scope, and the closest scope is whatever is within these curly braces, and of course including this thing. And it says, hey, you want to assign this x to itself. Doesn't look right, and that's why you have to add it like that. But of course there's a convention, and I think we'll talk about that, where you should write your, a lot of people do this, and it's a standard practice in most companies actually, or should be, where you write underscore and the variable name, right? And that's for the private fields. These things are called fields. So when they are in a class, the variables are actually called fields, not variables, right? You can call them variable for now if you want, but they are fields and functions, right? And when you declare it here, this is a variable, right? So now it says that an x doesn't exist. You have to write it like this. And you see now you don't have to write this dot whatever. It's a bit better. And just assume you have a lot of things written here, a lot of calculation stuff, and when you involve a field in that calculation, right? X plus 5 over 2 and stuff like that, you immediately know that, okay, if it has an underscore, then it's a field of this class. And of course there are a lot of editors. Like there's one called Rider, which is very popular with Unity, that colors your members differently. And a lot of people say, man, you don't have to do this anymore. You don't have to write underscore because it's colored pink or something like that, purple for you. But I don't agree with that. You just have to write it this way. And yeah, you just you want to write it this way because and for example, when you do git diff, when you like this, when you work with your team and you want to look, okay, what was changed, you maybe use a different git solution, and it won't necessarily color the fields like that, right? When you look, okay, what was changed and so on. Yeah, and Rider has its own git diff thing, but I still think you should write the fields of a class like this. So with an underscore. Good. So this is the constructor, and of course you can have multiple, multiple parameters and assign them, or do logic here like if whatever, assign whatever, and so on, right? Yeah, and in this case, we create the player with this health. So let's say we create the player with 100, and we give it a name, and we then set maximum health to 100 for the player. And it's called maximum health because you might want to just diminish the health. For example, the player might get take some damage or whatever, and then you don't know the percentage of like what's remaining. Do they have like 60% remaining health or 10%? And that's why you have to have this maximum health. And of course, you also need to have like a health. So you have maximum health and like current health, right? And at the beginning, maximum health is the same as current health, and it's not written here. Just imagine there's like public int current health, and that's the thing that you change when you like take a power up or whatever, or take damage. Yeah, so like blueprints, houses, you create many houses, and actually building a house from the blueprint, it's it's done like this: enemy, name of the variable, whatever you want, equals new enemy, and then you set enemy dot health is 100 if you want, like this, right? It doesn't have any constructor, so when you build it, you don't need to provide any parameters. And the default values of enemy's health will be 0, 0, and lots of variables would have the default value what you would expect, like the most neutral value possible. So for the strings, that would be null. And for classes, that would be also null. So again, new class, and we have like so now we have two fields in this class, right? And this will have the transform is the component from Unity. So from an object, right? So the transform is this class, this component here, this transform, right? The position, whatever, and it's a class, and because it's a class, its default value will be null. It will be null. So when we construct this class here, transform will be null, and basically because it's not public, if we make it public, and when you make it public, it's called property in C#, and you have to use Pascal case, basically. And we'll talk about, because this is still a field, but it's capitalized as a property because it's public. And you do like x dot equals whatever, you'll find the transform, whatever you want to do, right? Good. Yeah, and we're storing the instance in a variable, and with the player the same. So player, my player equals new player, and we give it 150 as health, and we call him Alex, right? These parameters here, and they are assigned here, and then our instance would have maximum health 150, and the name would be Alex. Loops. Actually, loops are a very important concept. And there's even a thing that's called, but goes like outside of programming, and it's just computer science in general, which is called Turing complete. And what that thing means is that a system is Turing complete if it can have some of these basic building blocks, like if statements, so that you can execute things based on conditions, so that if player is dead, then play a sound, else play another sound, like background music sound, right? And then you have loops, and there are some other things, and I don't remember exactly what, but they are like very fundamental concepts. And loops are a way of executing the same code multiple times without writing it like 10 times. You do it like this: for integer, for like I starting from 0, and as long as I is smaller, it's less than 10, execute this code. And I++ means increment the I, yes. And the way it works, it executes this thing, then it checks whether I is less than 10, and then executes the code, and then executes this thing. So it goes from here to here to here, and then to here, right? And you remember plus plus, we've done this a few days ago, or I don't remember when this is just the instruction for incrementing I. So it's the equivalent of writing I equals I plus 1, because equals is the assignment, right? Remember, it assigns the value on the right to the variable on the left. But this is the shorthand for it. It's y plus plus. It increments whatever the value I is. And let's say if this is 1 and not 10, you go from 0. 0 is smaller than 1. Code executes one time. Then you increment I from 0 to 1. And then you go here. So basically the second loop is attempting to start and checks, okay, is 1 less than 1? No, it's not. So then the loop ends. And then you just do it by, just imagine you can have any number here. You can have 1,000,000 here, right? And if you have it like 10, it will execute 10 times, but you have to start from 0, because I never reaches 10, or at least never reaches 10 inside this. So when this code will execute, I will go from 0 to 9. 1 second. So from 0 to 9. Yeah, and you remember in basically in math classes, you have that's sum, you know, don't remember, open board. I don't know, let's try it. You had that sum symbol. Yeah, well, for each loops always get me. They are even easier. You know that sum with I goes from 1 to 10, something like that. And this is equivalent to this is a, like, you write 4 or, and you press tab twice, and then you can do it like this. For int equals 0, I smaller than 10 plus plus I. The equivalent of this thing, the equivalent of this here is actually y is smaller or equal, like less than equal to 10. And in this case, it will actually go from 0 to 10, so 11 steps. So maybe you want it like this, from 1 to 10. This is how you do it, right? And of course, you can also do it from 10 to 0, or let's do just 1 because it's easier. And then you do it like this, greater or equal than 1. And here you'll have to do y minus minus. That's like the shortcut of decrementing y. So you start from I keep saying it in Romanian. From 10, then it checks whether it's greater or equal than 1, and then it does minus minus. So it executes it 10 times, right? Like if you have it like 2 here, it's all right. They execute it once, and then it decrements it, and then it's 1. Oh, twice. Yeah, it's executing it twice, and then it decrements it again, and it's 0, and 0 is not greater or equal than 0 than 1, and so yeah. So 10 times it executes it. Yeah, this is how you do loops, and I'm pretty sure I'm also talking about other loops. Yeah, for each. Yeah, I'm not talking about for each, but we'll talk about that. They're just the same thing. They are just loops, but small variations. So you have also the while loop, which is I mean, let's do this. Let's see how can we trigger this faster. So we have new class. Let's do it like this. So we create like a mono behavior so we can print from 10 to 9 when we press the button, right? We will go here. Okay, where are you? I mean, let's just add it here, right? New class. Count, right? And when we press the button, we should see from 10 to 1 here, 10 messages. So 10, 9, 8, whatever. This was executed in an instance because it's just very fast thing to execute. From 10 to 1. Good. And yeah, while loops. So while loop is like, I mean, the simplest form of loop is a while loop. So while a certain condition is true, do something. And we can do the same thing, right? So while I is, I mean, because I is not defined at this point because it's inside here. So when you define I, it's only accessible here inside, right? Let's comment this with control and forward slash, or command and forward slash, and do while, I mean, you basically just declare your variable as any other variable, right? While I is greater or equal than 1, we display I. And then, by the way, you can also write it on the left side and on the right side. You just try it at home, like try it at home and see what's the difference. There's a interesting difference there. But like at this line, it's the same. So after this is executed, doesn't matter if I do it like this or like this. Like after it executed at this line, the state is the same. Like I is 1 less, right? Good. So basically, you're just doing the for loop but manually, right? Because sometimes you have like, or even better, and you would want to do something like while is alive, debug.log. You won't do this because it would block Unity, because you'd have to do it some other way. But just for the sake of example, so while is alive, you would just call call this, and you'd see like I'm alive, I'm alive, I'm alive, whatever. I mean, in order to show this, let's do it actually. Just try to just go with it. Don't think about too much. Or I think you can do even no like that. Let's do it like that. So what this thing does, yeah, you have to import the collections.generic, I think. Oh no. Yeah, so just briefly, the way this works is an enumerator is this is a way of returning things one by one. So Unity has this mechanism which is called coroutines, and you do like start coroutine. This is a Unity function, and then you basically pass it the result of this function call. So you basically call this function. That's the order. It is the equivalent to this. Basically call it and give it the enumerator. And this start coroutine just calls next, 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 and that's how it works. And I know it's a bit confusing now, but I just want to show you this thing with the while loop. And what this thing does, it tells Unity, okay, I executed this. Now I yield the control to the Unity runtime for one frame. And you do your thing and then come back in the next frame. And if I'm alive, I will print again. And again, I will wait one frame and so on. Because if you don't do this and Unity executes this function, then the whole game will just stop. Will just stop because it will keep executing this function again and again, right? All over again. Let me just quit this thing. Yeah. And let's do that. Let's do that. I mean, let's make this public so you can see a thing. And because it's public, now we can see it here in the inspector. You see, is alive. And let's press the button. So the moment we press the button, this is called start coroutine. And let's do it. I mean, let's keep it like this so that it won't compile again. This will get called and it will enter here and it will just keep printing this until we either destroy the game object or just turn this into false, right? Good. Let's press it. Ah, interesting. You don't see it? So we press count, we do this while it's, oh, okay, because it's alive is false, right? We need to have it as true. You see, and it prints it one each frame. And we have like 200 frames. It prints like 200 times per second. Then we press it's alive again to turn it into false. And you see it stopped. And of course, now it doesn't start again because the way it works is, okay, while it's alive, execute this, execute it, and so on and so forth. And the first time it becomes false, it exits. It's the same thing as this thing. The first time this condition turns to false, it exits the loop. And that's how loops work, right? And that's how the for loop is like a specialized version of a while loop. And do while loop is exactly the same as a while loop, but basically it doesn't first check for the condition, but it automatically executes it at least once and then checks for the condition. And it's just a small variation where you want to execute your code once anyway, and then you have to see if, okay, will I execute it again or not, right? And yeah, there's also for each loop, and basically that's how Unity does coroutines. So you can actually force this thing to happen without a coroutine, but it will also be similar to just writing it without a coroutine, just like I said before, or like this thing, where it blocks Unity until it reaches this condition reaches false. You can do it like for each item in C. Doesn't it work like that? Oh, I know. Yeah, you basically have to do it while c.has next. Move next actually is this. Do something and then c dot current. So yeah, you do something here, and so the way it works, you call this thing, and you always return null, 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 and it will always have this is a special function in C#. So move next will return true if there's a value, because you can do it like this here. Yield 1, 2, 3, and then you do yield break. And this is your like the way it will work here. It will print I'm alive 1, I'm alive 2, I'm alive 3, and then c.move next will return false because you have yield break. Right, and that's how coroutines work. But it's just that you're giving Unity this, you're passing Unity to Unity this responsibility of calling move next and see current whatever, because Unity then calls all of its entire loop with like rendering, physics, sounds, networking stuff, and a lot of things there in the behind the scenes, like moves the cameras and everything. And that's why the game doesn't stop when you do this thing with the start coroutine, right? And of course, this is like the trick that Unity has created. But let's say you have a list, because we didn't really go in lists, but you define a list of things like this. So you put 2 square brackets. 1, 2, 3, 4, something like that, right? I have to remember this thing, yeah, because it's different I've done a lot of Python lately. Yeah, something like this. So that now you've defined a list of 4 items, right? And you do it like this when you iterate through a list. Let's do it again. So for y from 0 to items dot length, so this will give you 4. Right, let's like, so actually also do like -1, 0, and so on. So it will give you 6, right? So from 0 to 6, but not including 6, you will print all of the numbers from there. Items I, right? And the way it will work, so this is available, this is true in all programming languages. Indexing starts from 0. Except I think in Pascal, or I don't remember, there's a language where it starts from 1. But you start from 0. So this position is 0, 1, 2, 3, 4, 5. And that's why you are going from 0 towards item length, not including items length. So not including 6. So you go from 0 to 5. And then you will display all of the items, right? let's actually do that, right? Let's put it, because you'd usually do it like this because it's more visual. Like you are starting this coroutine. It's easier to understand. Good. So we're commenting it, so it's not executing. So we have 4, and we go from here to here, and we print those items. Yeah, you have to exit play mode and enter again. That's the recommended way. Don't listen to what other people say. Like it's alright or whatever. You just do it like that. Button. Oops. There was a delay. Again. Button. Okay. It went from 0, from -1 to 4, right? Bam. And for each, it's the same. Like for each I in items, you print I. I mean, it's not I, but it's item. Because I, it's this convention that I, it comes from the index, exactly like in maths, like you use I for the index, which is usually goes from 1 to n or whatever, and in programming goes from 0 to n minus 1. But here you're getting the item directly. So this is almost a shortcut for this. For your, I mean, you can just think of it as a shortcut, right? It's a bit more nuanced behind the scenes, but this is a shortcut for this. So if you don't need an I, for example, you don't want to print something like at index I value is item, right? So you kind of need I as well, right? But here, if you don't need it, you just do like item is item, right? So item is -1, 0, and so on and so forth. And yeah, most of the time you would use this thing if you don't need if you only need the value and you don't actually need to deal with the index and all of that. Yeah. Yeah, so for loops clearly state their intended start value, end value, and the increment. For example, you might want to jump every 2 elements, not one by one. So you can also do this thing. So I plus equals 2. So you go from 0 to 2 to 4, and then you will go directly to 6, which is definitely not smaller than 5. And that's how you'd jump to them. And you can even do like and you have that step like given to you as a parameter, and whatever you can do like y plus equals that step, right? Just if you have like a question, if something is possible, assume in 90%, 99% of cases that it's possible. Just to have to find out how. Oh, my stream I just discovered that my, okay, my camera on the stream was not aligned properly, but it's fine. Good. Okay. Yeah, and while loops are simpler, they first start by checking the condition, and do while loops first execute the code inside at least once. And Unity example, spawn 10 enemies prefabs at random positions. So you have number of enemies 10, and you spawn 10 enemies, right? And the way you do this, one way of doing it, is you do like vector tree spawn position. So you decide on where's the spawn position. And there's this API here, random.range from -5 to 5. And this basically gives you a number between -5 and 5, a random number. This is for the X component, so the horizontal left to right. And then we keep the Y component, so up, down. We'll keep it at 1 meter above ground. And for the Z, so forward and background, backwards, again, from -5 to 5. And now you have your position. And random range always returns a different number. So on your first enemy, there will be a number. On your second enemy, there will be another number, and so on. And actually, between these two calls of this function, so here you'll get a number, then the next number will be different, right? And so on. And yeah, then you instantiate, sorry, this is Unity's API to instantiate an object. And this is the equivalent of getting the prefab file from the project window into the scene. Like, you remember how we drag the stuff in our scene? So yeah, we get an object. We have to find our object here. I don't know, where is it? Like this prefab. We put it here, and that's instantiating the object. And that's exactly what this thing does. It's instantiating a game object instance that we get. For example, maybe we can expose it in inspector, like we're exposing this is alive here, right? We are writing here like right prefab, and we'll see it here, prefab, and we can put the prefab here, right? And now any instance of this script will have access to this prefab, and we can do basically this thing here: instantiate enemy prefab into the position, and this is just a shortcut towards to the 0 rotation. So it's just the default rotation, like 0 on X, 0 on Y, 0 on Z. You have to put it here. It's just because it asks for 3 parameters: the prefab, like what you want to instantiate, where, and what rotation. And yeah, this is how you specify the no rotation. Yeah, so short example in Unity. So you can do this if the visual animator animation tools in Unity don't work the way you like. So if you want to do some extra, some manual, some custom animation, you will do it directly in Unity. And this is the code. And I think, yeah, open. So thank God we already have it here. I don't have to write it again. Good. So week 2, day 3 should be C#, Unity. C# manual animator. Don't save. So we've created this script, which is very simple. So it's a mono behavior. We have the namespace correctly. And we have the sprite renderer. So it's the component that will animate. And remember, sprite renderer is a renderer. It's a component that allows you to display basically 2D images, which are called sprites in some places in Unity. So this is the renderer, and these will be the frames. So this is a list of sprites, which are images, right? And they are public, so we can assign them in inspector. And you see, I mean, this comment should not really be here. It should be obvious. Yeah. So we should have, we have them private here. And of course, I mean, don't really like the private word. Private is the default one, right? And also public, there's also a rule you should have the, I think just GPT wrote this for me. That's why, right? Yeah. These are public, so we assign them and customize them in Inspector. And these are private because they are like inside the class, and like the user shouldn't really know about them because it's not relevant. Index is the current sprite position, and timer, I think. Oh yeah, frame rate. Basically, frame rate means how many frames per second. So 10 means that in a second, 10 frames will happen. But it's the frame rate of the sprite renderer, not of your game, right? It's just you can customize it here. And if you remember from previous lessons, update, it's called once per frame. And basically timer, what we do here, we get like the time since the last frame and we add it to the timer. And basically the timer gives us the total real, like the time since the script started, like was born into existence, right? And like if timer is 1 over the frame rate, so if the frame rate is 1, means is 1 over 1, which gives you 1. So if 1 second passes, then we move to the next frame rate and so on. But it's like 10, then this thing will be called 10 times per second, right? It's just some maths. And the way we will do that, so we start from index 0, and we'll say like, okay, next index will be current index plus 1. And of course, it will go like over the number of frames. So frames.length is the number of frames. So let's say we have like 13 frames or something like that, right? And this is the modulo operator. And it's very simple, like if you've done some math. So maybe you have like 14 here, but you have only 13 frames. So 14 modulo 13, I think it's 2 or no, 1, it's 1. And then and that means that index, basically index, if frame you have 13 frames, index will go from 0 to 12, right? Because doing modulo 13, basically it loops back, 13 loops back to 0 and so on. And then you do sprite renderer dot sprite equals frames at index. So the first time is 0, and you basically get the frame at position 0, right? Until 12, if you have like 13 frames. And then you assign that frame to the sprite renderer. And then what you do, I have to understand what this thing does here. So if the timer, oh, okay, yeah, basically if you went, basically if it's the time to change the sprite, and it is, you execute it, and then you basically undo the thing. You basically go back, like, yeah, I don't really understand what this thing does here. But of course, you have to reset your timer. Of course, if you don't do anything, then this thing goes once here, and then it keeps. It will always be. I think. Oh yeah, it will always be true. So once it's true, it will always be true, right? Because this keeps incrementing, and you have to undo that thing. And I don't think it's the best way of doing it, or the most easy to understand. But yeah, that's how it works actually. Good. Just let's not think about it too much. It's just this. This is an example of how you can do an animation manually in code. Okay, and it's this, we create this object, we added the sprite renderer component, and you already know how to do that. And we added a script, and here are the frames. So a list is displayed like this with this arrow, expandable arrow. And I've already added these things here, but let me show you how to add them. Oops, Control Z. Let's put 0 here. So basically, if you write 0, you remove them. You have to lock it here, and basically whatever you select, it will stay locked. So now you can select all of them and drag them here. Bam, you see? And then unlock it. And frame rate is 10. And let's start it, and it should, yeah, this is 10. You can create any, you can add any frame rate you want. Yeah. Yeah, and now there will be a small pause. Let's see, so this thing took 2 hours until now. Let me estimate how much longer it will take. So just feel free to take a pause if you want. This is not supposed to be short, so any chance you have for a pause, just take it. Yeah, I think it will take like 2 more hours, something like that. Also, most of the things are mostly me talking, not really showing you code, so it might even take less than that. Just don't forget to hydrate. Very important. Just in 1 minute, something like that, I think. Just in 1 minute we'll start. Okay, so we're back. We're so back. Okay, so where do you save your code? Google Drive. Yeah, don't save your code on Google Drive or Dropbox. Use GitHub or Bitbucket or GitLab or whatever, right? Just store it in a proper Git repo. Good. We'll talk about C# best practices. A long list, so you can mess your code in so many ways. So these things are very important, and this is the moment we enter that part where we talk about advanced concepts, and yeah. So until now we talked about some of the beginner stuff, and it's not comprehensive. It's not like probably there are at least twice as many things you would need to know as a beginner for C# to learn C#. But yeah, like if you want to know some more concepts, I would just I recommend you that link that I've posted with that guy, which has a 4 hours in-depth course on C#. But for to create a game, you don't need to know more than this. Just go right into it. You'll use ChatGPT, Google, and you'll just get it. And you'll also like watch me next week and the week after when I am live coding a thing and I will explain stuff and so on and so forth. So that's the minimum amount of the minimum that you'll need to know to create your own games. So that's why I'm not going like in depth in the I'm not going into many details, right? So yeah, so these things are important, and save them somewhere, and you can come back in 5 or 10 years from now, so you can watch them, so you can level up, right? And if somebody who already has like 5 or 6 years of experience, I guarantee you, like I bet like 100% that you wouldn't know at least one thing on this list, because there are so many that it's like statistically impossible that you know them all. Maybe like 1% in 1,000 will know them all, because even I don't know 1,000 things that some other person knows, right? It's not just about me, it's about like just the fact that there are lots of things. Yeah, okay. So we're going right into it, and I'm starting with 2 acronyms. So this thing is called YAGNI, so you ain't gonna need it. Yeah, and so let's start with this one. Yeah, like I said, so what this thing means is don't implement stuff that you think you will need at a later time, and that you implement them and maybe you're using them after 1 month or something like that, right? So don't do that. Just implement stuff as you need them, and like okay, if you think it will take you like 5 minutes, but only 5 minutes to create something very simple that would save you weeks sometime along the line, maybe in 2 months or something like that. Yeah, but if it like takes you an hour to to code something that you will only need it after 2 months, just don't do it. Chances you won't even need it at some point, because for example, in my case, when I come to a moment when I have to, I'm thinking, okay, will I need this or not? The answer in 70% of time is no. I'm not gonna need it. But I'm only finding that answer in the future, because in the present I don't know. I'm just finding it after 1 month. I just find it and I say, oh, I didn't really need this, so I just spent 3 hours on that day and I wrote something that I didn't need. And yeah, I just don't implement stuff too preemptively. Just implement what you need now. Good. Yeah. Don't build frameworks. Don't build a physics engine. Don't build a game engine. Build your game, please. And I learned this the hard way. KISS, keep it simple, stupid. I think the first version was keep it stupid, simple, but a lot of people like it this way. Keep it simple, stupid. Don't recreate wheels. Find plugins and assets and templates that already exist for what you want, so you can focus on your awesome game instead. And yeah, I learned this the hard way as well. Oh man, so I've created so many things, so many wheels, and I've learned programming like that way. Like I've learned C# and Unity quite a lot, but I didn't really create something useful, right? So I was just learning in a way, but I'm like over learning, I guess, because I mean, it's better to just build something useful and learn at the same time. But in my case, I would just build small frameworks and all of those stuff. So keep it simple. And yeah, so if you have two choices to create a complex or a simple thing, just create the simple thing, and then you can create another simple thing and another simple thing, and then you can create a wrapper around them. So you can create like a bigger box where you put those simple things, and then you get a complex thing, but then you also understand each simple thing, and it's better this way. It's called composition in a way, but we'll talk about that later. Then dry. This is like this. I don't know. Is it the most important? I don't know if it's. I don't know if the order is in order of importance or not. Yeah, I don't know what USB drive. 8:30. So 6 minutes ago you said USB drive. I don't know what that means. You said USB drive. Colin. Yeah, but yeah, don't repeat yourself. This might be like the first on the list, actually. So if you have two pieces of code, like if you see that you're writing the same calculations over and over again, like you have, where are you? New class. You have like this. Um, so you have this thing here, and then you have it here, and then you have it here. Just don't do that, because if you want to change it, if you then find the bug and then you see, okay, I also have to put one here or whatever, you have to write it each time and it's just a mess, right? You create a function. My function, and this function will do that thing, right? Probably like it takes A or actually B, right? And it returns A. And then you'll do A equals, right? And then instead of okay, you have to press you have to press B, pass B. So instead of writing that thing, you just do this thing, right? Look how nice it is. You just call the function because it you have it in three places, right? And yeah, this is dry, the dry principle. Don't repeat yourself, right? Um, and imagine you have like very large function or large function, and when you need that functionality somewhere, you just copy paste it, and you have this mess. And when you have to modify it, you don't know which one you've modified. Maybe you fix a bug in one of them, and then you maybe fix another bug in the other one of them, so it's a mess, right? Well, if it's here, if you have a bug or if you need to improve it, right, you just write it here, right? Good. Reuse code as much as possible, but there's a catch. So I have this like, it's genetically in me. So I have this dry concept. So I am having it by default. I try to not repeat myself. I try to reuse code as much as possible. So I didn't have to learn this. But there's a caveat for that. So 2 sections of code are identical now, but they might change independently tomorrow. And this is a very nuanced thing that I haven't seen in any video, in any lecture that talks about the dry principle. So sometimes, because you don't only have the spatial dimension, you also have the time dimension. You have to look in the future. Like you have to see like frames of the life's movie in a way. Like, okay, now 2 sections look the same, but will they look the same tomorrow, in the sense that maybe the enemy, you have like a player and an enemy, and you have a calculation for the damage, right? And maybe it's the same, like attack minus defense, right? That's your like the simplest damage taking function, right? And they are the same in the player and the enemy. And you might have tendency to create a function, so you can call that function from the player and from the enemy as well, right? So that you have the same code in the same place. But if you foresee that your enemy's damage function will be different in the future than your player's function, it's okay to keep them duplicated. So basically you'd have the same 2 or 3 lines of code in one place and in another place, right? And just keep them like that, because they will have different reasons to change, most probably. And this is not like the best example, but there are other examples. But yeah, that's a place where you won't use the dry principle. So just because 2 pieces of code are identical doesn't necessarily mean that you would have to unify them in a function and then just call the function in both places, right? Let's say maybe the player would need to have an armor, right? And some not only defense, like armor and some other stuff there, but you still want to keep the enemy simple. Well, if you would have created the function and then you have to again split the function and change it and so on. Yeah, so I learned this the hard way, because I was trying to oversimplify the code, but there's a barrier where you don't have to simplify it. Yeah, and it's like a good visual for it. So you start with all this mess here, and through Yagni, so you ain't gonna need it. So you ain't gonna need the cloud, I don't know what else, the cylinder. Then you get closer to have the optimal simplicity and efficiency. Then keep it simple, stupid. So you don't need this thing and this complex shape and this with all of the functions that you'll never need. And then you have it like this. So you have basically you cut this through a square. You cut this to another square that's red. You cut this to a triangle and a sphere and so on. And dry, don't repeat yourself. So you see these things are in 2 places, and then you come from all this mess, and now this is how your code would look like, abstractly, symbolically speaking. Right. Let's see, could you use an abstract class and just have different implementation for those methods? Yeah, yeah. I mean, it doesn't, I don't know how it relates to this, but the answer is yes. So yeah, so an abstract class, it's like an interface in C#. So yeah, yeah, an abstract class is a class that defines how a class should be. So the functions don't have a body, so they only have the signature. So what they return, whether they are public or not, what they return, the name of the function, then the parameters, and that's it. And that has the signature. But the body is the what's between the curly braces. And in abstract functions or abstract classes, you don't have that there, because the abstract class is something you cannot instantiate. It's like a template for a class. And the class is a template for instances of that class. Yeah. Yeah, so tell me a story. Sorry, so so your code should tell a story. So when you go through your code, you should, let's see, do we have an example? We don't have an example. But what I was saying before. So when it's ambiguous, when your variable names are ambiguous and you're not explicitly saying what the variable is or does, or if somebody looks at your code, or if you look at your code after 2 months and you don't know what the code does, then you basically have to spend some time to understand it, and it's not efficient, right? And what most people do, they write comments. But if you can write, basically, if you can give your variables understandable names, you won't need to write comments, right? For example, you maybe have like take damage function, and you have a complex calculation there, and you have like base damage. So instead of I don't know, writing like x, a, b, whatever, you will write like base damage, then you modify it, and then modified damage, and then final damage, and whatever, right? So your or for example, when you collide with two enemies, and I don't know, if one of them is weaker and one of them is more powerful, and you want to somehow fight the more powerful one, you basically have a variable name. You'll create it and you'll name it the more powerful enemy, or powerful enemy, or weak enemy, or whatever, right? For some of you, like it seems obvious, but yeah, it needs to be said. And you'll only stumble upon this while just writing a lot of code. You'll see how much expressive you can get the moment you change your functions names and variable names to actually say what they do. So yeah, I should understand what your code does by just looking at the name of your class, its members, and the variables inside the functions. So if you have to write a comment to explain, then you're doing it wrong, right? Unless it's a complex algorithm, like you're doing like pathfinding algorithm, and you're explaining, or you're calling like a Google server for something, and you're explaining like, okay, we're not calling AWS because they are like banned in whatever in my country, or what, right? So comments are for things that cannot be expressed in code, right? So this function is called count, but it's not really obvious what it does, right? So if we want to have a good example, and of course, like we're just learning here, we've created a lot of things, but let's say we count from -1 to this one, and print items. This would be a better name, because it prints the items of the class. And if there are not multiple variables items, then it's obvious which ones, of course. But if you have like a lot of variables here, you have to basically say, okay, print red items or whatever, right? That's and then I understand what it means, right? Yeah, so I don't have more examples for this, but just remember this. Try to tell a story in your code if you want to understand it, right? Composition over inheritance. Yeah, like at this very moment, like I understand that if you've been here and you are like an absolute beginner, this is just the part where it will get a bit more confusing for you. But if you have programmed a lot, um, or just programmed at least for 2 or 3 years, you would get this, because these things are not tied to C# at all. They are just general things. And we didn't talk about inheritance that much, but I kind of explained you that inheritance is just when we inherit. So if we want to attach this to an object, we have to inherit from our behavior. So what this means is it's as if this class and all of its members, so imagine like these members are coming from this class, right? And at runtime, when you run your game, it's as if you are taking all of those members and putting them here, right? So you can access them. And this is called inheritance, because you inherit the other class's members. And yeah, you can inherit from, you can inherit from just one class, but that class can also inherit from other class, and you can have a very long chain of inheritance, right? And try to not do inheritance. Yeah, if of course, if you need to inherit from our behavior, that's a given. But like if you have, I don't, you have like a coffee machine. Yeah, I have like a coffee machine, and it does like, right? Okay, let's. So you have a coffee machine. It does coffee, and the coffee machine. Uh, so what does a coffee machine need? It needs like I don't know. It needs uh money grabber, like a money grabber, a sugar adder. I don't know. Uh, pour water and so on. And of course, like in C#, you can only inherit for a single class from a single class, and it's not that obvious now that you would inherit from the three of them, but there's sometimes a tendency, because it's easier to just inherit from a class, because if you can inherit from a class, let's say from a water source, you can just call its method, right? Pour water, or pour water, right? Because as I said, inheriting, it's as if you're taking all of the members of this class and putting them here. Almost like that. Yeah, and you see it says like, this hides inherited member pour water, right? Because if I mean, obviously, if I write it here, it's as if I'm hiding this one. Yeah, so just don't do this, because this is like overusing inheritance. So only do it when it makes sense. So only do it like, for example, you have here, it makes sense, because a boss, you can even call, it's better if you call it like this, right? And I have this thing like, even so here, I put 2 spaces between the variable names, and sometimes like I leave a space between public and private, but it doesn't really matter. But I have this thing I really like, and I saw it somewhere, and I'm keeping like that. Put 2 spaces between member fields, so fields and functions, or the constructor. Good. Here it makes sense, right? Enemy and boss enemy. So a boss enemy is an enemy. And it makes sense, like in 90% of cases, you do it like that. Good. But here, coffee machine, like you can do it like this, so you can write pour water directly, but then somebody has to give you the sugar added, and you can do like this. You can do like Alt and Enter, or Option Enter on Mac, and you can do generate constructor. Like if you're lazy, you don't want to write it yourself, right? And then somebody has to give you the money grabber. Then somebody has to give you the sugar adder. Right, and that's like you can do it also like this: generate field with again Alt and Enter, or Option and Enter. Yeah, and now basically you do like mg.grab money, then yeah, you can do Shift and Alt, Shift and Tab, or Tab to just do, tab, 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 Shift and Tab, Shift, Tab. Good. Sugar adder. Add sugar, right? And then pour water, right? But it's kind of messy, right? It's you're kind of using inheritance because you're lazy to pass the water source on the constructor. So just don't use it that way. You just pass it to the constructor. And I think you can do, let's see, you can do it like this. Add parameters to this, and you see it automatically adds them for you, so it's easier. And let's just remove that. And it's your coffee machine. And this is what's called composition, because you compose the coffee machine with various instances. And this is also how you get over the limitation in C# where you cannot inherit from multiple classes. Right? You cannot inherit like this. You can in other languages, and it's awesome, but it's also you have to really be careful. Cannot have multiple base classes, right? Yeah, and but it's not actually because we want to get over that. It's just that composition in itself, it's safer than inheritance. It's not safer, but it's cleaner. You have more control over it, right? Because you can have here like 100 things, right? So you have a coffee machine, and a coffee machine has a money grabber, has a sugar adder, and a water source. And this is like the process. You grab money, you add sugar, you pour water, something like that, right? Good. And that's actually, this is a very important concept, and I think they are like in order of importance. Just remember this for your whole life. Just do composition and inheritance only when it makes sense. And of course, you have to know when it makes sense. And I deleted it, but I've shown you that thing there. Oh, another thing, very important. Let's say you have like a very special coffee machine. And you might have this tendency to just put like this, right? And of course, we don't have to have these things here. Yeah, so the way it works, so because the base class needs these things, we have to also create a constructor here with these things. And we call base with these things. And it basically calls this thing here. So this is our very special coffee machine, and then maybe we have some custom things here. But in many cases, not even now does it make sense to use inheritance. So remember, we had like an enemy and like a boss enemy. But if and this is more of an art, but in this case, even in this case, maybe it's just better to still use just copy this thing over, and maybe you have a very special machine which, I don't know, doesn't use sugar but uses something different, right? And imagine like we've replaced that thing, and maybe we have that thing dot something here, right? Imagine that if you have used this coffee machine, you would have you needed to somehow create like a do coffee two, where you do this thing and you don't do this thing and you do this thing, and then you have the sugar adder, which was like a surplus and you wouldn't need it, and it's like messy, right? Because you have to um, delete some of the functions from the base class, and that's not good, right? You have to always like use as much as possible from the base class. If you're like throwing away half of the base class, it means that you're not using, you shouldn't use inheritance, and it's even called refused bequest. So you're refusing the inheritance, right? And it's a code smell. We'll talk about them later. Um, yeah, good. Good composition over inheritance. This is very important. And be as private as possible. This is also very important, but it's easier to understand. So encapsulate everything by default and only expose the class members if other classes need them. So I personally hate specifying private in C#, but most people recommend using it. I just like to keep my code as lean as possible, right? So it's simply implied by default, so I highly recommend not using it. Good. So, for example, a coffee machine has all of these things private, right? So it's private, everything's private. This function is not private because you have to call it from somewhere, from outside, right? And the constructor is also public because you have to construct the machine somehow, right? Unless you have like, so for example, maybe you want it like this, maybe you want to have full control over how you create your objects. So maybe you already have some default instances of this thing somewhere lying around, and you just want to call like coffee machine dot create default, right? So in that case, you'd have the constructor be private. So this is like a private constructor, right? And just imagine this is another class, and you just create a default coffee machine, right? And yeah, this is private. And I mean, let's briefly just sorry. Let's briefly just talk about so coffee machine, and take let's take the enemy and boss example. Good. And the enemy has this thing that's called attack. Okay. And in order for, so let's say by attacking, you just print 10. It's a simple thing. Let's say your boss enemy, you want your boss enemy to have a different value. You want it to print 20, right? And you cannot do it like this. So for example, you create an enemy. Yeah, by the way, you can do this directly if you want, but you'd usually like assign this to a variable, then call variable.attack, right? you want your boss enemy attack to call a different method, right? And it does, but yeah, actually we have to do it this way. It will actually use this function. But let's say like we have like, or yeah, let's actually do it like this. So basically, I'm just briefly showing you inheritance for functions because it's very simple concept when you use just the basic example. Good. So you have an enemy and you create an enemy instance and you specify attack. Let me turn the lights. Let me turn the lights. Bam, we have the lights. Good. Yeah, so we have enemy and boss enemy, and good. We created an enemy, and when you do attack, you see it also highlights it, and it shows you that it will use that method. Then we have the boss enemy, and when you have this, it will call this thing. But what you'll see, it shows here this message hides inherited member enemy dot attack. Use the new word if hiding was intended. And yeah, you can do this thing as well in some cases so that you'll specify your intention to just hide the base function. But usually you'd have to do it this way. Or let me show you why you have to do it, what I was about to show. So if you do current enemy equals E, so if you do it this way, so see that we have a variable of type enemy, right? And then we assign the enemy to the current enemy and we call attack. And then it's as expected. But what happens if we do this, BE? We can assign the value of boss enemy to a variable of a more base type, right? So now when at this line of code, we don't know, I mean, at least the runtime doesn't need to know whether it's holding an instance of this class or this class. And just when you call attack, it will use this function, right? Because the type of this variable is just enemy. And it says, okay, we are on enemy, it has an attack, it doesn't attack. Good, we call that one, right? But in order to, and imagine you have like 10 enemy types and then subtypes and so on and so forth. And you have like a current enemy somewhere in a function and you want, you're changing that current enemy for some, like maybe, I don't know, current enemy is like when this games since, I don't know, 10 years ago or 8 years ago, when a lot of games now, when you have 10 enemies, when you fight them, you only fight them one by one, and the other ones are just waiting for you. It's like you maybe have like a current enemy, right? And you have to fight him. And in order to like have this one called, no matter what's your variable type, you'd have to write this. That's what it's called. Public virtual void attack. So the base class, like it agrees to have this function be overridden. That's the term actually. And you can call override, and it automatically, I mean, it doesn't. You have to delete that thing. Oops. Override attack. You see, and now it does it like this. And it's not like the best example because it usually you should try to use as much of the base functionality as possible. So in this case, you'd call this thing and it will attack with 10 because you have to. So this is like the base, the default call that you have to do, base.attack. So what this does, when you press attack here, it goes here directly, and this thing decides, okay, will I call the base as well? And in our case, we don't want to call the base because we are already doing the base's work here with 20, right? But generally, you will have to use the base functionality. So now it will work. So now here, when we press attack, even though our variable is of type enemy, this attack will basically, the runtime will say, okay, we are of enemy of type enemy. Okay, let's go. Okay, this is a virtual type. Let me now look whether this instance is actually this enemy or there's another kind of enemy, and it says, oh, okay, it's of type boss enemy, and boss enemy overrides this method. Okay, so let me call this method, and that's everything it does. And then this method decides, okay, do I also call base dot attack, right? And usually you would need to do that, like in like 95% of cases you would need to do that, in most cases. But in this very specific case, because this like already gives 10 damage, right? We don't want to give 10 damage and again 20 damage. We just directly do 20 damage. And that's inheritance for you. You can look at it in that, guys, for our stream or lesson. Yeah, so and be as private as possible. So have these things private because nobody needs them from outside. And it also keeps it clean when you do coffee machine. You only see here like do coffee, right? You don't want to see MG, SG, and so on and so forth, right? Do coffee because it's easier. So yeah, even like a teacher on at college told me that some rocket failures and like a tragedy happened because people didn't use private. So, but I don't remember exactly the specifics, and he was very vocal about it. Just use encapsulation. That's what it's called, encapsulation. Early optimization is the root of all evil. This is like, if you're an experienced programmer, you're probably tired of hearing this, but it's very true. Focus on making your code work and only then consider making work faster, right? And I have this tendency to optimize, early optimize as well. And I mean, I fought it and I won mostly. But yeah, some of us just like to optimize things and just focus on making your game work, because in 90% of cases you won't need optimization, right? Just make it work. Focus on the game's logic, right? Not how will you display some 100 trees instead of just 50 or whatever, right? Just make it work and just display triangles, green triangles instead of trees, right? Just so your game will work and you have a working prototype and you'll advance the next step or whatever, right? Just think broadly. So move forward with your game broadly, not deeply, right? So make sure you have a playable level and something you can show to your users or investors or whatever, right? Feature creep. This is kind of people that have this early optimization thing, probably they might also tend to have this. But this is a very powerful virus, which happens in all of the applications in the programming. And for example, I used the file manager app on Android a long time ago. And man, at some point, like that file manager app turned into like almost like a social media app. Like I would see posts from other people and like, man, that's just a file manager. So yeah, see you. Just you can see the, you can look at the, you can look at the recording because it's long. Yeah. Yeah, and basically feature creep happens everywhere, also in games. So it's one of those things that prevent you from launching as well. So you're just saying, okay, one more thing, one more feature, and you just don't launch in time. But also in your roadmap, like, okay, you are working on something that you know has to be done, but then you also say, okay, let's also do this thing because it's well needed or it's good or whatever. But this thing just compounds over time, and you suddenly have some features that you have to maintain, and maybe your game even breaks at some point because of those features that you didn't even need in first place. And it's kind of a more general philosophy. It doesn't even relate to programming, right? Because you can also do this in real life. So just try to identify this like feature creeping, right? Yeah, and exactly. So it leads to increased complexity, potential user confusion, and the dilution of the original vision. So try to only focus on what's on your roadmap, right? Yeah. Don't bet the house on the shiny new thing. And this is so every tool, including Unity and especially Unity, constantly adds new features, and new plugins, new platforms, and most of them are awesome. But the problem is just don't be the first one to use them, or at least if you have a lot of spare time, just experiment with them. But don't bet the house, meaning that don't bet the next 10 or the next 2 years of development on the new features, which might not work, or new versions. For example, now we have Unity 6, and just give it like at least 2 years until you just base your project off of it, unless you are willing to wait a lot until they fix some issues or whatever, because yeah, they're fixing a lot of issues and fast, but some of the issues might even last 1 year, right, until you get a fix for them. And it's available like it's true for a lot of software. It's not only for Unity. So yeah, so for example, we use Unity 2022, if I remember correctly, in this tutorial, just because it's the most stable at this point. So yeah, currently the rule is just get whatever Unity is the latest, then just subtract 2 years. And of course, like Unity itself comes with a lot of functionality, new functionality, and you want to, okay, I want that in my game, but just try to not create your game. Just don't make your game about its features. Make your game about its gameplay. So, and your unique idea or your unique insights, right? Or whatever. Don't implement features, but make games, right? That's like a very important distinction. Yeah. Yeah, most new features target early adopters and those who want to explore and stuff more than finishing the game. Yeah, so you have to clearly ask yourself, do you want to explore or do you want to build? So Yeah, and having 50-50, I mean, you can have 50-50 as well, right? Just make sure you ask yourself. Yeah, and remember that for most games you also have maintenance, and even like years after release, depending on your game. So a single player might live 5 to 10 years if it's a good one. I don't know, and the multiplayer might even live like 10 plus years, right? World of Warcraft even lives even now, right? Like, I mean, it has over a decade. Um, would you build on an unstable foundation? Yeah, and that's why I said like try to integrate things that are time tested, battle tested, right? Good. Size matters, so classes try to keep them less than 500 lines of code, right? Something like this. So this is already too much, but I'm being generous here, very generous. I mean, no, 500 it's all right. I mean, it's a good practical. Some people would say like 200 or whatever, but no, just be practical, you know. I mean, at some point it's just easier to put everything in one file, and I have like files of 2K lines because it's maybe a very complex plugin and I want it to be all in the same file. But most of the time just under 500 lines, right? Functions below 50 lines of code. And of course, you might have very complex functions, right? You might have very complex functions. Well, in that case, just separate them. Just take this thing and just create another function out of it, right? Just create another function out of it and then call that function this here. And of course, it might need some parameters and you would need to write again some parameters, right? But it's still better. And just use specific names, use very expressive names. And most of the times you'll also find that yeah, there's something more complex that I wanted to say, but it's not very important now. But yeah, it's this thing that extract functionality inside functions so you can make them smaller. And arguments in a function. So there's a book, Clean Code by Bob Martin, and he said something like 2 parameters are the maximum, because if you need like 3 parameters, you can basically turn them into one class and you then pass an instance of that class. Like instead of passing, where are you? These things here, right? You pass this, like a class containing the parameters, right? And it's better that way because maybe you then want to add a lot of parameters to it. And then you won't need to add a lot of things here as well. Because you already have the parameters class, right? That's the reason. But a more practical limit is 5. So it's just my limit. I just like it this way. So I'm trying to not have more than like 3 or 4, but let's say I just want 5. Just it's very generous limit, right? So, but don't have 6, right? If you have 6, then just create the parameters class or inputs or whatever you want to call them, or just split it into 2 functions and so on and so forth. Theory versus practice. Yeah, this already looks like a lot of theory and not so much practice. So yeah, we're just getting started. All of this information is for later if you're just getting started in programming or want to just you're here for the Unity stuff. But yeah, store it somewhere in your head, or just you'll have the link on YouTube there, and come back in the following years when you want to upgrade from junior programmer to middle programmer or even more, because I mean, not even senior programmers know a lot of these things, and especially in game development, because in game development people are more heretic. They are more not disciplined, because it's kind of this thing where you know, you're allowed to be more of a an artist, more of an, you know, and an artist, like good artists don't really listen to other people. They just go into it, and it's kind of this battle between not listening and being disciplined, right? And but if you can be a game developer that also follows best practice and code patterns, you're like one in, I don't know, 1 in 10,000 or something like that, or I don't know, 1 in 1,000. And that's why I'm saying this is very important, because yeah, people in gaming have this tendency to have less discipline and have a less structured code and follow fewer practices. Good. And like I said, some I will do a lot of practice on week 4 and some on week 3 and some even tomorrow on Unity when I will just code the small thing. So there will be a lot of practice. Solid. So this is another thing that Bob Martin created, if I remember correctly, and yeah, it's a set of principles for purists. Yeah, separation of concerns, open closed principle, list of substitution, okay, interface segregation, dependency inversion. Yeah. Separation of concerns. What this means is you don't create a big class with a lot of things in it, but you separate concerns. Like if your class processes some data and then it also prints that data, then it does two things, right? And yeah, you should have two classes for that. You should have like input processor and then content printer or whatever, right? And you have two classes and one does a thing, the other one does another thing. Yeah, a class should have a single unambiguous purpose, and the method function should also do one thing only. Like, and you shouldn't like follow this thing completely, but you should kind of have it as a compass, as your guideline in the programming life. Yeah, example of a function, a class's functionality, controlling player movement, right? And you have like 500 of lines of code for controlling player movement. That's fine. So open closed principle. So this thing you would understand if you wrote some more software. So software entities like modules, and in our cases like namespaces, let's say, classes, functions, etc., should be open for extension but closed for modification. So our example is not that great here because we don't respect that thing. Where is it? With enemy here, because I mean, this is a bit a different thing, but let's say, so instead of modifying section of code in a class, create a new class. So example, we have a melee boss, or no, melee boss, a ranged boss, are separate and derived from the boss class. So yeah, instead of having so let's see. Yeah, so you shouldn't have like a melee boss and then ranged boss inherit from melee boss, and then you just change the range and change a lot of things there. Just have a small boss class which has, it can even be an empty class, like just boss and no functions, no anything. And then you have melee boss which inherits from boss, and then ranged boss which inherits from boss, and then they have their own things there. So that's what open close principle means. So you shouldn't deny a lot of functionality from the base class or change it by a lot, right? If you see yourself doing that, just create a new class and inherit from another class. Yeah. And Liskov substitution principle is closely tied to this thing. So subclasses should not break whatever they inherit from the base class. But this is a bit... so the difference is, imagine you have a square class. So a square which has what properties does a square have? A square has only the edge length, right? But then you have also the rectangle class, which it has like the large edge and the smaller edge, right? So the width and height, let's say, yeah. And let's say like the rectangle is a class, and you try to have a square class which inherits from rectangle, but that's not, that will violate this principle. And why? Because the rectangle assumes that you can set the width and height separately, right? Because you can set the width to 5, you can set the height to 2, and then you can again modify the height, and the width doesn't change. But if you inherit the square from rectangle, suddenly now when you change the height, you have to write custom code to also change the width, right? And you also use uh, twice the memory for the width and the height, but they are always the same. So just create another class, a completely separate class that has only um, width or height or whatever you want to call it, right? Because you only need one number, and for rectangle you need two numbers. And if you do it the wrong way with this square, when you set height and width, height or width, and then you automatically set the other one to be the same size, maybe some code in the rectangle doesn't know that, because if you're in the rectangle class, you then assume, okay, this is a rectangle, so if I modify the height, the width stays the same, right? Makes sense. But if somebody um, like if square inherits from rectangle, then it basically forces some of the assumptions that the rectangle does to be false. So that's Liskov substitution principle. And it's called substitution because if you have a class of type rectangle, a variable of type rectangle, and you assign it a rectangle, and you call, I don't know, something, calculate area or something like that. Not calculate area. Yeah, I don't really remember an example here, but if you assign an instance of rectangle to a variable of type rectangle and you call all of its functions, it should behave the same as if you create a square instance, if it inherits from rectangle, and you assign it to that variable of type rectangle, and you call all of its functions, right? It's that's basically what substitution principle means. But yeah, I don't feel like showing an example of this. Yeah, maybe 1% of you understood because it wasn't really good explanation. But the first part you understood, right? With a rectangle, with width and height, which can be changed independently, but in a square cannot be changed. And it breaks like the contract with the rectangle. Good. Yeah, this is an example. So you have a rectangle, and this is like somewhat of a natural language. That's what it's called. So it's schematic language. So the rectangle has a height and a width, and a square inherits from rectangle. And you write some code to keep height and width in sync, as you'd expect in a square. And you do r equals new rectangle, and you set h to 1, w to 2, and you do s equals new square, you set h to 1, and you set w to 2. In the first case, rh is 1, while the second case, sh, it's 2. Yeah, so like in this case, h remains 1, but in this case, when we set width to 2, height also has to change to 2, right, automatically, by using this custom code that you write. I mean, yeah, this is like another way of visualizing the Liskov substitution principle. If it looks like a duck, quacks like a duck, but needs batteries, you probably have the wrong abstraction. So you also have this analogy when people teach inheritance, like in object-oriented programming, when you have like an animal and is a base class. Then you have a duck as a derived class that inherits from base class, or you have like duck, bear, dog, whatever, right? But in this case, like you cannot, for example, have the class animal and have the duck inherit from animal and also the rubber duck inherit from animal, because they are so different that you basically like they are like 95% different, right? And you'll write a lot of custom code to just account for that difference. And for example, this thing would need to have the base class animal, right? And this thing would have to have base class toy, because this thing is more a toy than it is an animal, right? And this thing is more of I mean, it's only an animal. And yeah, then you shouldn't have like a common base class for this thing, or you shouldn't even have like one of them being the base class of another, so that you have like a duck, and then you have the rubber duck inheriting from the duck, because then you'd have to throw away a lot of functionalities of the real duck, like breathing or whatever, right? And you'd basically again do this refused bequest code smell, it's called, where you have to throw away a lot of functionality of the base class in order for your derived class that inherits from it to work. Yeah, so a base class functionality shouldn't be altered, but there are some cases where it was specifically designed for modifications, like an empty frame you're expected to build around. There are generally better ways, like interfaces, but this is sometimes an acceptable exception. So yeah, like maybe you have like a base class, which that's its own purpose to be a base class for something, and all of its methods are either abstract or don't have a body, and they basically welcome you to uh, add functionality to it. You don't actually change functionality. You are adding. You're filling a void. You're filling an empty space, and that's sometimes acceptable. But yeah, like you would use interfaces for that. Like interfaces are. Let's talk now about that as well, right? So you have this interface. So an interface is just a class which doesn't have function bodies. It has only functions and properties. Int health. And yeah, it's this thing in the C# where instead of writing, you do it like this. And this is a property. And the way it works, it's cool because now you can publicly get the value, but you cannot publicly modify the value. So someone who has an instance of this class can get its value, but cannot set, cannot do like new enemy dot or whatever. You have like a reference to the instance equals 1, right? It cannot do this thing. And so interfaces can have properties and functions, right? And this is like the convention or I character, right? So a character has health and attack, and this is like a contract. And in some languages, in some project actually, you really call these contracts because they are like a set of rules of about how a class should behave, what it should have, right? And you can do it like this. So this interface tells you that, okay, whoever implements, that's what the terminology implements, the interface needs to have a health property and an attack function and you don't write public or whatever, because they should be public by default. And then you can have I don't know, I maybe you have like maybe you have like this thing. So you have an interface, and yeah, of course, with interfaces you can implement as many as you want, and that's the cool thing, because they don't have a body. There's no conflict there, right? You can have as many as you want. So there's they only define what a class should have and not how it should behave, right? So you have like callable. I don't know if that's a word, but you can invent a lot of words in programming, and you should, because naming things is one of the hardest things in programming. Callable. So this is an interface which allows, for example, creates a contract for any class that implements it to collide with other collidable object. And yeah, of course, you can just reference it itself here. Why not? And you see it says enemy does not implement interface member collide. And you do Alt and Enter, and you implement it here. And it basically creates it for you, right? Collide. And now you basically implement this one. And yeah, you can do a lot of things like this. And you can do the same with this coffee grabber. So you can have like an interface for money grabber and so on and so forth. And then whoever creates the coffee machine actually has to create the classes and defines exactly what they need. But the coffee machine doesn't care how these things work. The coffee machine only knows that it has to call grab money, then call add sugar, call pour water. And of course, this should be like in a separate file that's called coffee machine for separation, right? And this is those are interfaces. And yeah, I tried to help absolute beginners as well, but yeah, I try to also not go too much into basics. Yeah, so okay. Interface segregation principle. Subclasses shouldn't be forced to inherit stuff they don't use. And this is like, I think, the fourth time that I'm invoking this refused bequest anti-pattern, bad pattern, bad thing. So instead of having like an I world factory, separate them into smaller I grunt factory, orc factory, peasant factory, and so on and so forth. Because, for example, maybe you have, I mean, let's do it, right? And you do like create orc, create, and create whatever was there, human. I know it was something else, but doesn't matter. And instead of having this, I mean, you can have it like this. If it's so simple, then keep it like that. But if it's if this function is very complex, or actually like if you, because this is just an interface, you have to create the class to define how it actually creates them, right? Implement interface, and it does it automatically for you. And yeah, you create something here, then something here, and so on. Yeah, but let's say that you want to, this thing becomes so complex that you want to somehow create now a player factory, and grunt factory, right? And then you do like throw not implemented exception here and so on. So basically you're refusing to implement these things, right? Because you want only this to only be, anyway, you got the idea. So you only want this thing here, grunt factory, right? And for that case, then you have to create I grant factory. Grant. Right? And then I human factory, right? And so on. And then let your classes choose what interface they want to implement, right? So if you have a grunt factory, it only implements the grunt factory, right? So you won't have all of these things hanging around and you're just not doing anything with them, right? Because it's just wasted space. And not only that. And that's what segregation means. So the word segregation is just the opposite of aggregation, right? So instead of having a very big interface, just have a lot of interfaces and just it's separation of concerns, right? One of the first principles we talked about. Then dependency inversion principle. So high-level modules, the bigger picture, shouldn't depend on lower-level modules, the nitty-gritty details. And we talked about this in this coffee machine here. So the coffee machine doesn't need to know how do you grab money or how do you add sugar. And like specifically, it's very important that it doesn't know. Because if it doesn't know, then it can make better decisions on a higher level. And it's exactly the same like in a hierarchy in company, like the more details you tell to your manager, the worse they will do their job. So just try to keep the details for you, and only when they ask you, or if you think it's extremely important that the company would lose a lot of money or whatever, just talk about it. So yeah, so higher level modules should not know about lower level modules. So money grabber maybe has like 400 lines of code, but the coffee machine class and its file, if it's the only thing in the file, will just have this code and it's all clean and nice. And then you can, you know, better manipulate the smaller components. And this is fractalic. So you also go in the money grabber. Maybe the money grabber has a lot of input parameters here or dependencies which it handles as well, and so on, right? So you apply it recursively. Yeah, so your scene manager shouldn't care how you load your resources for a specific scene. It just knows that what scene to load and basically load it, because I mean, in case of Unity, there's a class that does that. But you'll have then a resource manager that does that. And this is more of a general concept, and which means that there's also stuff like dependency injection, which is a very popular keyword in programming, which follows this principle. I mean, it basically means that for example, me, I am a coffee machine. Where's my okay? I'm a coffee machine, so I shouldn't care where do I get these from. They are just given to me, right? So this is like spares me from a lot of you know, so a lot of I don't remember that word. I just don't have to think about too many things, right? So I get these things. I know what to do with them. Money grabber grabs money, adds sugar, per water, whatever. Yeah, I don't care who gives them to me, right? I just get them in constructor. And there are dependency injection frameworks and so on and so forth. It's like learning a new language. Like some plugins that instead of adding these things here, they are like automatically assigned to you here, right? But the most fundamental type of dependency injection is already how the programming languages were made. So the simplest form of dependency injection is just passing stuff in the constructor. right? It's so you already have dependency injection, and some I think it's also called like poor man's dependency injection because it's just by default you're doing it, and you're basically you have to manually declare these things here and assign them here. But it would be nicer if you just declare them, you add the attribute, that's what it's called. I don't know, just an attribute, inject. That's like an attribute, right? And it does it for you automatically, right? And it's good, like it's less code, it's amazing. It just it adds some performance issues, but generally it's good to use, right? It's good to use, and we'll talk about it later. Yeah, and Solid is a guideline, and it's not low. Use it as a guideline. And another break. uh, yeah, another break. So feel free to go to the bathroom or whatever, right? And I will also look and see how much more time do we get. Have we got? Yeah, it'll take 1 more hour. Just hang in there. But anyway, you can, of course, see the recording tomorrow, right? If you are tired or whatever. But yeah, man, initially I thought I could do this and the Unity part. Wow, in the same day. There's no way. I need some more water, but I think I'll do without it. Yeah, 1 minute. Let's relax for a bit. Let me take some fresh air. And we're back. Need a beer by this point. We are past water. Oh, well, if I drink a beer, I will need to sleep. I don't know. It's kind of beer makes me want to sleep. But 3 beers kind of wake you up, and 6 beers again put you to sleep, something like that. It's like a sinusoidal function. Actually, yeah, some people that are naturally anxious could probably write better code after maybe 300 milliliters of beer or something like that. Like that would be like strike the the best balance. Yeah. Yeah. 3 beers and write the best code of your life. Then the next day you delete everything. Yeah, man. Some water. So there's this thing. A lot of people say this, and I hear this a lot of times. Like maybe I don't know, like at 3 p.m., 4 p.m. Like people say, "Oh man, it was such a hard day. I need a coffee or whatever." But I think in most cases you just need like half a liter of uh, water. Maybe you saw me like right around the 7 p.m. or something like that. I like drink a lot of water because that's and even when you kind of when speak, I don't know. I think you just lose water, just evaporates. But yeah. Anyway, like at the 3 p.m., 4 p.m., 5 p.m., like I suddenly feel like I have to drink a lot of water, and I sometimes like drink a lot. And man, it gives you such an energy boost. Like there's nothing that can energize you uh in like that naturally and that quick. And yeah, and that's what I say, like if you are don't feel like you have energy, just drink like half a liter of water and just wait 15 minutes, and if you still don't have energy, then just go into tea or coffee or whatever. Yeah. All right, let's see. Let's get serious and clean some code. Yeah, code smells. They are exactly the sound like. You see it and you instantly understand why it stinks if you're a good programmer. So cleaning it is as unpleasant as it's necessary to avoid chronic disease. Large class. So basically, we've already talked about that. So below 500 lines of code, right? So if you have a really large class, it suggests that it has too many responsibilities, right? Just split it into lots of smaller classes, or I mean, 2 smaller classes or whatever. Yeah. Example, a user class that handles user details, authentication, and notifications, right? And you'll see this is a lot, like this is kind of the rule in a lot of things. But if you can start right from the beginning with avoiding these things, like your life would be so easier, so easy. Yeah, and sometimes there are some assets, some plugins that have large classes so that you can have an easier time to use them. For example, there's a thing called .twin for Unity. And in order to use it in code, like it has a lot of functionalities, and you only write .twin dot whatever functionality you need from it, and then you have lots of functions in the stuff. And that's kind of a good acceptable middle ground, because or not middle ground, but that's like an acceptable exception because it's a plugin, and instead of having a lot of different names for classes, for utilities and everything, like .twin animation, .twin different animation, .twin color animation, .twin whatever. It's just a .twin, and then you press dot and you see all the functionalities, and that's like a good um, compromise, right? But most of the time, if we are talking about your code, just try to not have large class. So this is a code smell. That's what they're called. Large class, right? Don't have large classes. Long method, the same thing. So have your methods below like 50 lines of code, right? And it's also harder to understand. Imagine like you have a long method, lots of for loops, addition and so on. But imagine then you have a long, not a long, but you have a method, you replace it with a method which calls lots of other methods that are smaller. If you can imagine that, it's like you're reading a story. Remember I said just tell me a story? You have a long method which says pour sugar, pour water, or take money, serve coffee, and you basically see the timeline. It's so beautiful to see, and like it's very easy to maintain, and it's like a perfectionist thing. It's a thing that you have to do. So there are like perfectionist things, and they are here as well, some of them, and those are some, and there are also things that you have to do, and just don't write bug methods, um, unless like you're on a tight deadline or something, right? It's not like the world is burning if you write long methods, but it's a strong guideline. It's a guideline, but on the stronger side. Yeah, so a single method that performs validation of the inputs, like password to have a minimum amount of characters and whatever, processes data, or like, yeah, sends it to the database, and also handles database and UI updates and updates the UI. So it's not that a method shouldn't do this, but if a method does a lot of things, it should do it by calling other methods, right? That's what it should do. So it can do a lot of things, but if it takes 30 lines of code and you basically call 30 different functions, then it's fine, right? It's doing a lot, but you keep it under 50 lines of code. Primitive obsession, this is a thing like I can only like give you a very simple example. So using strings or integers to represent complex data structures, such as a string for a phone number without validation or operation methods. Yeah, I have to think about something here. But basically it means instead of creating a class like phone number class, you basically use a string. And most of the time, and I think even in 95% of cases, people still use them, and it's fine. But you basically have to process it, because if you let the user input the phone number, they can put like a plus, like a parenthesis, and all of that. And you'd better be off just storing it as a number. So you just write on the input side. So instead of mitigating it, just be proactive. And when the user inputs their phone number, you just strip every other character that's not a number, right? And maybe keep a plus if they put a plus at the beginning, and just store that as a number, right? Or but there are better examples. I don't remember them now, but basically don't use like integers or strings to represent data that's a bit more complex in nature. Damn it, I would let me find something. Primitive obsession example. There's also this site called refactoring.guru, which is amazing. One second. Yeah, like another simple, it's not a perfect example, but simple example is, for example, instead of using enums, and yeah, in C# enums are these things. Yeah, something like this. So like instead of using like states, you would use numbers like okay, you have to be in a class to you basically use something like this. And const means you cannot change it. Int yeah, and basically you'd do these things. That's what's called primitive obsession, because like primitives are data types which are like numbers, strings, bools. So value types which are not like classes or structs, right? And those are, so instead of using like an enum, proper enum, so that you can write x equals state.idle, right? You would basically try to jungle with these things with like var x equals state idle, and you have to assign a number to it, and maybe you say, okay, between starting and stopping, I actually would want to do another like in progress, whatever, and now I have to modify this thing and whatever, and oh, but now in some place I assume that stopping was always 3 because I was doing like var speed equals whatever x times state stopping, but now because stopping is 4, it's this thing with primitive obsession. So and this is like, I think maybe just 20% of the examples that are representative, but this is like a good way of saying them. But Python, for example, uses a lot of these things. So I mean, sometimes they are good, but as a rule, just try to use like enums, or use, for example, for a phone number, just create a class that's called phone number, right? And it has the number, right? And you have it like that, and then you have a prefix, and so on and so forth, right? And try to store it that way. And of course, when you store it in the database, just you store it like as a string, but you'll have full control over it. Don't store it exactly like the user inputted it, right? Good, state idle in progress. Yeah, so basically instead of this, do this. Good. Primitive obsession. Data clumps. So different parts of the code contain the same group of variables, indicating a missing class. So passing the same 3 or 4 parameters like start date, end date, and user in many method signatures. So instead of this, create a class and call it like user activity, right? And you just pass an instance of that class, right? And then you can add a lot of parameters here, right? You can add 10 parameters here, and then you don't need to change the signatures of all the functions. That's a mess. God object. So an object that knows too much or does too much. So it's the opposite of the single responsibility principle, which we'll talk about, I think. So like example is a manager class that handles database access, business logic, and user interface rendering. In Unity, we don't really care about rendering. It's done kind of automatically. But yeah, so an object that it's kind of the large class code smell usually overlaps with this God object code smell, where you have a class that does everything. Like you can like write the whole game in a in a class, right? Shotgun surgery. This actually um, describes what will happen if you do this code smell. So making a single modification requires changes to many classes or methods, potentially breaking lots of things, right? So example is like needing to add a new field to a form requires changes in the database, several business logic classes, the UI layer, and 12 hours of downtime. So basically, you have a complex app, game, whatever, and you want to you have a loading screen and your game starts. But now, let's say between your loading screen and your game starting, you want another like dialogue. So you where you want to ask your player the difficulty of your game, and you already have the difficulty implemented. It's already in your settings in main menu, but now between your loading screen and actually starting the game, you have to add this step of asking for the difficulty, right? And it's easy to create like the difficulty screen and everything, but maybe in code you assumed that the difficulty is already set in the main menu, from the main menu, and you've already kind of made a lot of decisions there, and it's very hard to change, and you just have to change a lot of classes, and you're like instead of changing 5 classes, you would need to change files. You'd have to change maybe 20 of them. I don't know. In a big game project where you have thousands of files, this happens, and that's why it's called shotgun surgery. So it's like you're operating someone with shotgun. Feature envy. So a method, and in programming, and at least in C# in Java, generally you can call a function a method, and more specifically, people prefer to call methods when they are part of a class. So when they are members, and functions when they are not like, they are still like members, static members, but they don't they cannot access the other members of the class because they are like separated. And yeah, so method, function, usually just can call them either way. I actually prefer function, but I use method also. Yeah, so a method that seems more interested in a class other than the one it actually is in. So for example, an invoice method, so that a method that creates an invoice for your client, right? If we're talking about an application or not a game, right? That accesses, so an invoice method that accesses multiple getters of a customer object instead of asking the customer object to perform an operation on its behalf. Yeah, something like that. So you have like an invoice and you have like a customer object, and I mean this is not like the best example, but let's say an invoice needs the customer's name, address, and some of the details. I don't know, and it basically says customer dot address, customer dot name, customer dot whatever, tax ID, whatever, and instead of that, just you can just have a method on the customer and call it get summary, right? It's not like the best way of doing it, but it's still a small, a good upgrade. So you just call customer dot get summary or something like that, and then you use that in the invoice, and just it returns a string directly with just all of the information that you need. And again, it's not the best way of doing it, but it's kind of an example of, instead of uh, constantly just uh, getting like, instead of constantly looking inside the class to understand what it has so you can get things out of it, just ask it what you really want, like what's your end goal, like I want that, right? And the class should give that information to you in a structured way. Good. Divergent change. When one class is commonly changed in different ways for different reasons. So let's see. If you find yourself altering the same class for formatting in output, updating database records, and validating data, the class is subject to divergent change. It does too many things, yeah. And this probably ties into with the large class as well. Code smell. So the way it works, it's a bit more nuanced, this thing, and only after you program for a lot of years you see this thing. So it usually happens again when the class is too large. So a class should only have one reason to change, or another other way. How should I put it other way? So if a class is formatting output, it's again updating database and validating data, like I said here. You probably will have to have 3 classes, or like in 3 different files, so that when you want to, for example, I don't know, maybe you want to update your password, database password. You don't hard code it, hopefully, but let's say you hard code it, and like if you want to change your database password, the file that also is formatting output shouldn't change, right? Because in version control, you'd have this file or whatever, and you are basically in the version control, when you see that a file changed, you are probably assuming what changed in that file. So if a file is called data validator, but it also does database operations, like it stores or reads stuff from database, and you change like the database password, but in Git you see like data validator changed, that file changed, you will assume that there were some data validation changes. Maybe there was a bug, maybe people were allowed to create the password with one character only. In like it's like you're consuming energy and time, which is money, to go and see, okay, it's important, like my colleague changed the data validator and he wasn't allowed to. Let me look. And the colleague just changed the database password. So he just, like, he didn't do the restricted thing, like, but you're just spending time. And that's why trying to create smaller classes that do just one thing is better, because when you see them changed, you kind of already know what changed in them, right? And I just had this epiphany now while I'm talking about it, because otherwise, like, I haven't. I just was overlapping this in my head with just having a large class with more responsibilities than needed. Speculative generality is overlaps with the concept of with that saying, optimization is the root of all evil. And the Yagni, like the first thing we talked about, like you ain't gonna need it. So code that is added to support anticipated future features that never get used, that potentially never get used. Example. So an overly generalized class hierarchy or interface that has methods no one ever calls. So you have like an animal class because you have a game with just animals that just hanging in a 2D plane, and let's say like a dog with run towards a cat and so on. And they have just this functionality. You need them to move and to rotate and so on and so forth. But you add a lot of other functions like a feed, like pee and so on, right? But you don't have those functionalities now, and nobody asked for them. But to imagine like, okay, maybe I'll need that in the future, right? And that's like speculative generality, right? Or I mean, actually, speculative generality is not exactly that. Is yeah, like you try to generalize things a lot. It's kind of tangential with what I've said, but yeah, let's say like you have the functionality of running, right? So you have a cat and a dog, and they have the functionality of running, but they run the same. They have 4 legs and so on and so forth. But you like create a class that's called runner, or a running module, and like you're using a composition, like in the sense that you're passing that exactly like in the coffee machine, you're passing the water source. You're passing that instance of a runner module to the dog and to the cat, and then you call like runner module that run with this, like with the cat or with the dog, and then so you're trying to generalize, like you're anticipating, like, okay, I will have other objects, like I'll have like a sphere that will run or whatever, and I need this runner module, like, and that's what's called speculative generality, because you're expecting that at some point you'll need to generalize it, right? But you don't need it now, and you don't even know when you will need it, and like that's a very big time sink. Don't do that. Focus on striking a balance between some generality and immediate need. Time is precious, and just focus more in immediate need. Inappropriate intimacy. So when a class knows too much about the details of another class, and this kind of is like a sister of this concept, so it's very related to this code smell. Like directly accessing another class's fields instead of using getter and setter methods. But it goes even more than that. It's like, so let's say like I have a boss enemy, I don't know, ground factory. But it's basically doing something like this, doing like instance. So I don't know, let's do it like this. Let's do it ground factory, and the ground factory has, I don't know, just for example, for sake of example. So ground factory has a character, enemy, boss enemy has, okay. And we have, so that's what inappropriate intimacy code smell means. B dot boss enemy. Oh. Dot factory dot c dot attack. Right. So I know it kind of I'm using this a lot of times, and this is not a very strong guideline, but it is a guideline, and most of the time, like if you're doing something like this, attack or health, whatever, just do this, like right, and then do c dot attack, whatever. But not only that, just try to also like apply this thing, like I said, from here. So try to ask for the thing directly, instead of asking an object to ask the other object to ask the other object to ask the other object to give the thing, right? Because, for example, maybe the factory will rename this thing to some other thing, but of course you can you can rename things automatically here, like you can do like this, and you just rename them, right? Whatever you want. But the thing is that a lot of files will change and whatever. But if you want to do like, okay, boss enemy, let it have a method like factory char attack, right? And you have this thing, and let it do the work, right? And then you can also have this private, right? Encapsulation is good. And don't worry about internal, just think about public and internal being synonyms, right? Just use public by default, it's easier to understand. For now, they are synonyms. And you can do factory.c.attack, right? That's what it's called. So instead of doing this, so that you try to know, okay, the intricacies of this class, what it has, then what this class has, then what this class has, then you simply tell it, man, I know we have a factory and a character attack, or you can be even less specific. You can just tell it attack or whatever, and it knows itself. It knows what to do, right? Like this is my way of describing it. Probably somebody could describe it even better. I don't know. Okay. Okay. Good. Good. What else? Refused bequest. We've talked like 5 times about this before, and in this session, and it's really important, and probably you remember it. So when a subclass does not use methods and properties inherited from its parent class, it might be inheriting from the wrong class, right? So, for example, a subclass that overrides an inherited method just to throw an exception indicating that the method is not supported. Yeah, this thing is, again, just not generally recommended because you just write a lot of code that does nothing and it looks bad, right? I won't go too much in it because I already talked about it. Message chains occurs when a client requests a chain of objects in order to perform some action. Demeter's law violation. So accessing a deep method or property through a long chain of method calls like this. Yeah, this is very similar to inappropriate intimacy. And I think it generally refers to just method calls as well, like this thing. And it like it kind of feels like the same thing as in inappropriate intimacy, but this refers mostly uh, to the visual aspect, to the aesthetic aspect of it, because it doesn't look really good. And trust me, there's even longer chains. So this dot A, get B, get C, do something, whatever, do something too, right? So this focuses on the aesthetic part. It says, okay, it just says it looks bad. But the inappropriate intimacy says that you shouldn't know too much about a class and about its other classes, right? Another break, but we won't have a break. Let's just jump right into it because it's pretty late. But I mean, I can stay here even for 2 hours. Doesn't matter. But I think maybe just 30 more minutes and we're done. Yeah. When you see bad code in your favorite programming language, look how they massacred my boy. Yeah. Just avoid code smells. And we'll talk about design patterns, and in some of them I'll try to also show you how it works. So this thing ensures that the class has only one instance and provides a global point of access to it. For example, database connection manager in an app that requires a shared access point to a database throughout its life cycle. So in this case, you would not need to always create write new database connection manager, new database connection. You just create it once and then use it throughout your whole application. It's not always the best, or I mean, it really depends on the case. Sorry, but yeah, a lot of time that's actually a lot of times that's actually what I used. Select asset. Let's see if maybe there's something here that I've missed. C sharp, Unity. Wait, actually, this I don't need this. C sharp Unity manual animator. Oh, okay, so we don't need it. Yeah, so singleton. Let's go in code. The simplest way to write a singleton in Unity is this. let's just call it database. What is this? Okay, I have to put the type as well. Okay, I don't need the read only here. I mean, I actually can do it. I can do it like this. So this is a singleton, and you can have a lot of things here like public void get data, right? And you get data here. And now when you want to use this thing, so the way it works, when you first access this class, it will create this instance of itself. And you also declare a private constructor if you wanted to, and I mean, it's recommended, that's like the pattern, so that nobody can create another instance of it. You only have one instance of it, right? And like in constructor, you can do like connect to your database, and you're doing it once, right? And you do it like, where is it? Here, like db.instance.get data, right? So you don't need to do new db, right, and assign it to, right? You don't need to do this, right? And it doesn't even allow you because the constructor is inaccessible due to its protection level, right? And yeah, that's how singletons work. And there's a lot of things that can work like this. For example, if you want to have lots of information about like shared globally in your game or app, but like just be careful about that, because you have the tendency to write everything there, right? Because if you want to share state throughout your application, and like the path of least resistance is to go here and just put everything in a singleton, right? Because you can access this DB from here, for example, right? You can go here, DB, and you see DB instance, and so basically you can access it from everywhere, and that will lead to a lot of headaches. Just try to only do this for the very important things that cannot be done otherwise. If you want to be like a purist and a perfectionist, you might make it so that you never will need a singleton. So you would use like, there are things that are called scriptable objects and other things. But yeah, just try to only use it for very important things, or when you're getting started, when you create your prototype. Factory method pattern so defines an interface for creating an object, but lets subclasses alter the type of objects that will be created. For example, a logistics management application that can create different types of transport objects like track, shipped, ship, uh, based on delivery context. Yeah, so this is a very simple thing. Like, let's say we've already kind of created these things, factory, but they are factory classes. And this is a factory method. I mean, let's just talk about classes because the method is very similar. So you have a factory. Let's create like create unit, right? Let's do it like this. You have a factory, you know, let's unit. So many things. Yeah, you have units and you have a factory that creates units, right? And then you have right? Which implements factory. Yeah. Implement. And so grant factory creates grants, blah, 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 and then returns grant. Then you have a human factory, which creates humans. And maybe human factory needs, for example, for human factory, maybe you need material. So you have right, and then you create when you create the human factory. You see, you can do this as well. You see, and it assigns it. So then when you create a new human factory, you have to give it a material, right? So that's why like factors are really good. Another one reason why they are very good, because then you just you maybe just have a factory, like you have f, and then somebody assigns it, and you don't care what it assigns it to, but you do f dot create unit, right? And you just get your unit here, right? You got your unit. And you don't care if it's a human factory which needed a material, or it was a grant factory which doesn't need anything. You just have a factory and you create the unit, and that's it. Because you are maybe I don't know, maybe you're a main, or I mean the class which you are in is like a unit coordinator or whatever, and it just creates unit using other classes and moves them somewhere, but doesn't care how they are created, right? And that's how the factory pattern works. And this is like the method factory pattern, which is a bit different than class factory, which we've done, but yeah, this is actually which we've described here. Just don't worry about this thing. Is boring. This thing is like this is what we talked about it now. Yeah, families or related or dependent object without specifying their concrete classes. A UI toolkit that can render widgets in multiple styles, Windows, macOS, without specifying concrete class version. Yeah, well, it's just my example is better. I mean, this is still my example, but the current example is better. Strategy pattern. Strategy pattern is just a thing that it's left as if you're deciding, okay, um, is it raining outside? Then I'll be creating something else. If it's sunny outside, I'll be creating something else. So it's very simple. It's like an if-else thing, but it's like more formalized and generalized. For example, you define a family of algorithms. So defines a family of algorithms, encapsulates each one, and makes them interchangeable. Yeah, and another algorithm chooses the best one at runtime. For example, let's see, a navigation app that can calculate routes based on different strategies, whether it's the shortest, the fastest, or the least traffic. So yeah, you have, it's really the same thing. So let's say you have I nav algorithm, right? And let's say you have shortest path algo, or what else? Cheapest path algo, let's say, right? So you have two implementation of the nav algo, right? Compute, and it gives you an integer. Let's say it should give you like a path, a list of integers or whatever, right? The list of integers. So basically the checkpoints that you have to go through. Compute. Okay, and then you have somewhere in your code, you have like, okay, I don't know, if I'm rich, then so you'll do like algo. So you declare the variable. So you declare the variable, And if I'm rich, then I'll go equals new. Actually, it's the other one. Cheapest path algo, right? Else shortest path algo. And then I do like path equals compute, right? So I don't care how it computes it once. So this is one job. So the job of deciding which one to use, and you can even have like an algo chooser class. So you can separate concerns, right? And you like have choose. And you're doing it here, right? And which is cool about separating concerns. I said previously, if you remember, like I was about to explain something, but it was too complex and not important, but I'll do it now. You see, like first you have to declare this here and then assign it and then use it. But here, if you extract the functionality and use a small function for everything instead of one big function, you can do this directly. So if is rich, you can directly return. Wait, I had it backwards. Shortest. I can do that like that. So if it's rich, return a new instance of the shortest path algo. Otherwise, we return this thing because return just stops execution because it like cuts the execution short because you already have your result. So if it is rich, return this algo. Otherwise, return the cheapest algo. And you do this like algo equals new algo chooser, right? So this is like two tasks: the task of choosing the algorithm and the task of computing the path, right? Yeah, and you can be explicit. Oh, it's not like this. It's new algo chooser dot, and I have to put make this public because otherwise I cannot see it. And yeah, you can also explicitly name the parameters, right? And now I can also have var here, right? And now I can do this thing, right? So just composition. That's a bit like tangent there. But the strategy pattern is this thing where you do like if it's rich, I use an algorithm. If it's not rich, I use a different algorithm. And you can have like, I don't know, based on age groups, like you have 10 different algorithms, right? Good. Observer pattern defines one-to-many dependency between objects so that when one object changes, all of its dependents are notified and updated. Example, a weather station that broadcasts weather updates to multiple displays. Current conditions, statistics, displays, forecast displays. So this is more of an example on an infrastructure, not exactly in a game. But of course, you can have a game like, imagine you have like various images here, right? So you have various images. Image. One is for temperature, one is for, I don't know, humidity, one is for number of players, and so on and so forth. And you have, they have a class, you attach the class here, and you have like a weather manager or something like that. And that weather manager has yeah, basically in the observer pattern, you literally create your interface. Like you have weather observer, and you have it like on something like this, and you have like weather observable, and basically the weather observable. I have to remember how this works, right? Because I've used so many things, but it's always different. Basically, I have a class, right? And weather observable. The weather observable inherits from observable, and basically the observable knows about the observers. I think it's not like the observer knows about the observable. Let me look into this. The observer pattern. 1 second, now I'll see it. Come on, man, C#. Well, observer pattern, I don't know, Java. Example. Yeah, you have like a subject and an observer. And yeah, the subject notifies the observers. And you don't even need like an observable example. You just need this thing like yeah, I think you have two patterns, like the observer and the observable or something like that. And you have a list of observer, by the way, a list. This is like a better way of writing this. I mean, this is like an array, and which is not resizable. So you create it first, like so, like you create an array of two objects. That's what they're called, an array and a list, and they have a very similar. They are just a bunch of objects, but when you create it like this, you cannot resize it. You have two slots, right? But with a list, I mean, you can just create a new one and assign it again, but you cannot modify this in memory. You can modify the individual values, but not the size of it. But with a list, you can do. Yeah. Observers or subscribers. Yeah, and you basically do this observers.add observer. And let's say you have a very complex, or I mean, you have some things here. You have like let's say this is like a moral behavior, and Unity calls update for you. Of course, you attach it to an object, weather observable, and on update you do something like if changed. You go through for each. Observer in observables. Let's say you do a sanity check, like if observer is not null. It's not like generally you shouldn't need to do this, because you should when an observer dies or whatever, you should remove it from here. But let's say like if observer is not null, observer that on temperature updated, and you have like if changed, you go get temp, right? You have like a method somewhere that gets the temp, and you update the observer, right? And that's how the observable pattern works. And currently you don't have any observer, but let's say like you have I don't know, your UI is an observer of the temperature, or your player's health bar, or your game logic is an observer of weather. Maybe when weather changes, the next wave of enemies comes, and the weather can change as a result of anything else. I don't know, right? So you have like, but let's keep it simple. So class weather temp. So you have like a model behavior which you attach to an object, and you have like you have to. So again, Alt and Enter or Option and Enter to show this menu. Where you see that red underlining, right? UI. This is an image from UI, right? And you also like this thing implements the observer pattern. I mean, it implements the weather observer interface. Implement interface. So when on temperature updated, well, actually, this I need the text. Actually, like remember text mesh pro? Basically, this is like the new way of showing text, the new way from very long time ago, but still the new way. The older one was just text. Yeah, we'll do it this way. Temperature text, right? So when the temperature changes, we just do text, the text, that's its property. You see it's a string, you can get or set it. And yeah, you have to, you can either do it like to string, so it can be converted to string, or you can do this thing. If you combine it with a string, the result will be a string, like so text. So this is your model behavior, which you attach to anywhere you want, and you assign which text should change when the temperature changes, right? And I mean, you also have to hook these things up. So inside another class, let's say in start, where I think I'm outside of a class here. So you see in start, remember it's where when an object is created. So you do, okay, you have the observable, which you, I don't know, maybe you get it, maybe it's this, a component, it's the same, it's attached to the same object, so you do get component. And this mono behavior, maybe, I don't know, somebody assigns it in inspector for you. And you basically do weather observable dot subscribe this indicator. So basically somebody has to tell the weather manager that let's call this weather source. So let's call it just the observer pattern, not the observable. Yeah, so somebody has to tell this weather source, okay, this thing wants to subscribe to you, right? And then you have can have a lot of things, and a lot of things in your game can change as a result of this thing. And that's how it works, right? And this, you also attach this thing to another thing. And again, when you do this, you will see like that property here. I don't know, I have to, yeah, you'll see it here. Basically, this blocking object is an enum that's exposed, whatever, and you see it here, and you can configure it, right? Good. Let's go back here, and I think here I figured out the observer pattern. And the observable pattern, it's kind of the opposite, if I remember correctly, where is it or is it not? So no, this is it. Just don't worry about it. Just this is the observer pattern, and that's all. Then you have decorator pattern. So it allows It allows for the dynamic addition of responsibilities to objects without modifying their existing code. For example, a text editing app which allows formatting, so bold, italics, underline to text without changing the original text class. Yeah, so the way this works, I don't know if I can write this fast enough, but it's like text formatter. And if I remember correctly, like you have a decorator. And yeah, so Unity allows you to have these things. Sorry, I talk too much. So Unity allows you to have this decorator things, which I mean, generally, let me show you an image. Let me show an image first. Yeah, I mean, let's talk about this thing here. Refactoring Guru. This is a interesting site. It's a popular site about just coding patterns and stuff like this. Let's see if it's what I was searching for. Yeah, so you have a class that's a decorator, right? I then have this is like an abstract class, which is like an interface, so it doesn't have too many components, right? And these are the concrete decorators. So these are the basically they define the exact thing that has to happen. So you have one decorator. So it's, imagine just like the bold decorator, the italics decorator on a text formatting class, right? And what you can do, so you have this component. So decorators are components, right? Yeah, so a decorator is a component, and the concrete decorator is a decorator, and so on. And you have your some kind of component. So let's say, I don't know, like default text, right? And basically what you can do, your decorator takes a component and executes an operation on that component. And by default, your operation, what is so base text would just return your text, right? It just return your text. But then if you add a bold decorator, it will return a bold text, right? And the way you'd use them is you'd, for example, you have your base component here, and then you can choose, okay, do you want to have them bolded, or do you want to have them italics and so on? And you can wrap them, I think, right? Like this. So you can create, let's say this is the bold decorator, which you basically, this is the pattern. You create it and you pass it the base component. And then if you also want italics, you create again you create the italics one, and you pass it the one that's bolded, and so on. And at the end, like, you just can call the operation, this operation on the final composed thing, right? And like they're using a bit different thing here. I think they are just adding some text to the text, right? So client, I get a simple component. Okay. Result, concrete component. Client code. Yeah, okay. And they have like a client which just takes a component and prints the operation result. Good. And then in this thing, client, now I've got a decorated component, and result is concrete decorator B that wraps concrete decorator A, and so on. And you see a pattern here. If you're if you're a web developer, with tags in XML or styles that are expressed in XML. And it's the same thing. That's how you wrap things, right? And this thing also works like there's also a pizza creating example. When you have your pizza is a base component, and then you add pepperoni, you add tomatoes and toppings and everything. It's really the same thing, and you can add them in any order, or you can like have different rules about the order. And what is cool about it is that they have a base component which has an operation, and the operation for the base um pizza thing, it just returns the simplest form of the pizza, right? And then you have a decorator for a base class for decorator, which takes the component and just does something on it. And like we have pepperoni decorator and tomato decorator and so on. Good. Yeah. Well, what a nice thing. Okay, I can just use that guy's examples. Good. Adapter pattern. Enables objects with incompatible interfaces to collaborate. So integrated with a third-party library for payments, but adapting the library's interface to match the app's existing payment module. I don't know if I should talk too much about this, but it's basically, instead of doing a lot of work there's a lot to talk about this. Let's see if this guy has a simpler surely. Yeah, this is like an adapter pattern. So you have the railway, but you want to transport a car. The car knows how to transport itself, but not on the railway, and then you need this adapter. Right? It's pretty simple. If you remember like this, like it's already you're halfway through understanding it, right? Yeah, for example, you have a stock data provider that gives you their ancient, and I know this. I've worked with this, and they give you XML, and but your analytics library needs JSON, and then you need some thing to convert it, right? You create an adapter, and I don't know, is there any yeah, it is like, I don't know, Ruby or what is this? I don't know. Anyway, you have an adapter which does stuff for you, and more often than not, people just don't use the thing. They just like try to adapt the code directly where it's needed instead of extracting all of that adapting logic in a separate class, which is really called XML to JSON adapter or something like that, right? So it does only that thing, and it's explicit and it's intentional, and you show what you want to do, not like do it all in the same method. And you see how if you kind of follow 60 or 70% of all these patterns, the remaining 30% they kind of follow from them, right? It's kind of those things where if you clean most of your room, somehow the last 30% of it kind of not cleans itself, but it kind of you clean it anyway. Like you're more inclined to clean it, right? It's kind of this thing. But in programming, it's even more direct, because it's not that you are inclined to also clean the remaining 30%, but it's just that the remaining 30% is cleaned as a result of cleaning the first 70%, right? Because there's a lot of overlap between the patterns. Command pattern, yeah, it encapsulates a request as an object, thereby allowing it for sequences, queues, and undo operations. For example, a paint application where each action performed is stored and can be undone with 100% accuracy. And yeah, like ideally, I would also show you examples of this. Let's see if this guy has examples. Command pattern. Yeah. So is this thing, so conceptually you probably understood it. So you have like I mean, in games it's not really, you don't really get the need for this, but let's say you're working on an app, which of course you can also create apps, and this is really well put here. Like when you save, we have lots of things and people try to receive them, and it's a chaos if you don't have a command or pattern. So a command pattern, you have a sequence of actions that you apply to a class, right? To a class, or to an instance of a class. And just the simplest way possible, just imagine you have like a list of commands, right? And when you execute a command, you basically call its execute function and you add it to a list. And then when you execute another command, you then pass your object to that command, then execute it, and so on and so forth, and you add it to a list. And when you want to undo, that each command knows how to undo the thing. For example, if a command doubles the transparency of an object, undoing it is just, you have to halve the transparency, right? And it kind of works. I mean, it works. Like if you have like 100 operations, very complex, very like, you look at it, you just say, man, this is impossible. But just by following this rule, each command knows how to undo what it did. Obviously, you can go from a very complex thing to the very beginning, right? And just navigate through the timeline. Yeah, and I don't know. Let's see if they have a. Yeah, I don't think we'll look into this thing now. And yeah, I won't show any code for this because you want to use it in games, but it's very powerful concept, and I'm already just described it to you. Just the simplest way of doing it is with a list of commands, yeah, and just do it like that. Good. State pattern allows an object to alter its behavior when its internal state changes. Leads to finite state machines, FSMs. For example, an online order system where an order can transition through various states. New approved ships delivered with behavior changing in each state. So the way this works, you have like a base class. Then you have, I don't know, new approved delivered. New state. Yeah, and the state has this operation, has execute, right? And let's make it abstract, because we don't need to basically show. Yeah, we don't need any function body here, right? Let's see, state. Oh, okay. Let's call it like I don't know, pizza state. and of course implement abstract class. And we just won't write anything here because it's just for example. And let's say you have like a pizza state executor and it I don't know, just something because we need a function to write things in it. Let's say you have like pizza state, current state, and you have like a sequences of states, and yeah, I don't know. Let's say like it's here. It's like a field, and somebody changes it, and on do you do current state dot execute right? And I think we can also like have next state known by this thing and execute, and then that's it. And somebody else then changes this to, let's say this is like kind of public, uh, or maybe you have something like mm, yeah, I don't know. So maybe you have it something like this. It won't be like this, but come on, man. Don't want. Okay. So you do something like and you have like I mean it's 0 by default, which is first one, and then you don't need this thing here. So current state, next state. So current state uh so what we're doing here, we have like a state executor, and when somebody, this is like public, and somebody when says okay do, and it starts first as like getting the next state, or let's like do it like this, because first is 0 and we want that, and then we increment it as a current state. This is one way of doing it. Like it's not perfect, but it's one way of doing it. Current state equals next state. Advance to next state, right? And it also it gives it to you. And you do current state dot execute, right? And again somebody calls do, and then you advance to next state and execute. And the nice thing is that you can ask, okay, what state am I in, right? I mean, let's make it even better. So let's have it -1 by default, right? So you are in no state, but when you advance in state for the first time, you basically go into the new state, and because -1 plus 1 equals 0, and you then get this at 0 state, bam, and you have this first state, right? And now basically you can ask, what state am I in? You know this number here. And the nice thing is because we have this base class, we have this execute like contract in a way. I mean, not contract, just forget about that word because it's complex. You have this execute here, and each state has a very well, it has a well-defined structure. What it does, okay, it has a function, an execute function, and it has to execute some things, right? And that's the state. And you can also have a lot of logic here. Like you can have a state can have a lot of steps, like a prepare, I don't know, prepare, uh, investigate, print, format, send notification, whatever. And each state can either choose to do something or skip a sub step, or do a step differently, and so on and so forth. But um, your executor would not actually need to know things how things are done here, right? It just calls execute. And it's a nice, clean way of showing a state and modeling a state, right? In our concrete example, like you have a pizza, you have like a new order state, and then you approve the order state, and then you have more states when it's preparing, and then you have like the delivered state, and so on and so forth. Template method pattern defines the skeleton of an algorithm in the superclass, but lets the subclass override specific steps without changing its structure. Example, a framework for data processing where the steps to pre-process, analyze, post-process data are defined for subclasses to implement. You remember we talked about like when you create a base class where it has empty empty methods, empty functions, and which is specifically made for subclasses to implement them, to add logic to them, and it's kind of this thing, method pattern, and yeah, so it's method pattern. So it's either a single method which you have to. This is a very simple concept. So I mean, I think we've already like created it. So you have like we've already created like nav algo, right? And it has this abstract class nav algo, public virtual void, compute, right? Or abstract, because we don't need to provide a body here. Okay, and then you have like my nav algo, which is very simple. It's so really simple. Compute, and this is where you actually write your algorithm, right? And you pass this nav algo, like you pass this as this instance. So you do like whatever new my nav algo. But maybe you have like a lot of this. Maybe you have nav algo 2 or 3 or whatever, right? But your function here doesn't shouldn't like need to know what algo you're using, you know. No. So this function takes nav algo, right? So this type, and because all of my 3 algorithms inherit from this thing, I basically have them here like A, B, C, right? And I'm basically calling my function with whatever I want here, like with C, something like this, right? And the function doesn't know, the function just calls the thing. And that's basically the template in a way. This is the template, but of course, like you can have compute, I don't know, run, print, and whatever. And just like the template class. And it's not that important really. Yeah. proxy pattern, a placeholder for another object to control access to it, either for delaying its creation, controlling access, or providing a location agnostic way of accessing the object. Example, a virtual proxy in a file management system for loading images only when they're shown. Oh yeah, this is really amazing. I mean, it's really important to know this. So image proxy. So we have an image proxy, and let's say you have a thing like string file path. I mean, if the path doesn't change, you just mark it as read only. This is a good practice. And let's create like the constructor, and it will assign it for us. Nice. And then we have like, this is a Unity's class, texture2d, get data, right? And this is like an image proxy. So instead of passing around textures, so like maybe you have an algorithm or a very complex system, or let's say just that you have player, and player has an icon, or a player, let's call it player data. So it's like a class. It's not like a model behavior or something. It's just a class that contains player data, and you have like public string name, public string level, which is, I mean, this should be an integer. And then you have image proxy icon, right? And imagine you create like 100 players or whatever you have like 100 players, right? New player data, and you have like 100 players. You create a for loop with 100 players, whatever. You don't need to read the images, right? You only read it when you need it. So your player data contains an icon, but it contains a proxy to the icon. In order to really read it, read all bytes, file path, and then you transform it to create, I don't know how you do it, but basically you texture 2d dot read file. Yeah, I don't remember. But yeah, you read the bytes and you create the texture here, right? And whatever, and you return yeah, you basically convert the bytes to the texture and return, right? But you delay the reading of it from the disk, right? So you delay the reading because you don't really need it when you create the player. You need it only when you want to display its icon in the leaderboard or somewhere, right? And that's what the proxy is. And this is a very powerful concept, and I've learned it like in, I don't know, maybe 3 or 4 years ago, and I've used it sparingly. I didn't know it's called this way, but yeah, it's really useful. Let's see how much. So yeah, Colin. Yeah, see you tomorrow. It's already late, I know. Let's see. What else? So we have this chain of responsibility. Yeah, we're pretty close. So chain of responsibility pattern passes the request along a chain of handlers. So each handler decides either to process the request or pass it to the next handler. For example, an email filtering system where multiple filters like spam, important business checks the email in sequence and processes or pass it accordingly. This also, like if you're a backend developer, you recognize this immediately. Like these are your middlewares, right? So when your request comes in, you have a lot of middlewares, and they just get the request, get some information about it, maybe change it, then pass it to the next handler, and so on, right? And I mean, this is really interesting to implement as well. But yeah, I mean, let's do it. So you have, I mean, I'm pretty sure this thing, I think is also on the refactoring guru. Because it's pretty easy to visualize. I'm pretty sure he has some responsibility, yeah. So it's like passing a bucket to one another. This guy, you know, drops the bucket on himself and so on. Let's see the code. Let's see code examples. Okay, you have like a handler, and you can handle a request. Yeah, it's exactly like the web request. You have a request, and it's like the interface for your handler, and you have like the abstract handler implements the handler, and yeah, you have to set the next handler, and we'll see below how that's done. And you will basically handle the object here. Yeah, and this is like the base logic. So if the next handler is not null, we pass it to the next handler. So basically this next handler dot handle, right? But if there's no more handle to handle the object, we are handling it, right? We're basically doing the thing here. Okay, monkey handler, squirrel handler, dog handler. Yeah, so this monkey handler, what does it do? So if request as string is a banana, so if basically request object equals has the value banana, we return monkey, I'll eat the banana, right? Otherwise, it means it's not for us. So we return like we do like base.handle that request, which will do this thing here for the like it will go to the next handler. Or return null if there's no handler, right? And for squirrel, the same. So if request is a not, I'll read the not. And otherwise, I'll pass the responsibility of handling the request to the base handler, which again tries to use the same code here as we'll go to the next handler if there's any. Dog handler, so meatball. So if the request is meatball, I am handling the request, so I'm returning dog. I'll eat the meatball. Otherwise, base will handle the request. And let's see here in the client, we have the client means like in web development, I think the client code is usually suited to work with a single handler. In most cases, it's not even aware that a handler is part of a chain. Yeah, so this is like trying 3 examples in a for loop to be easier. So first you'll handle the not. So food will have the not, will have this value, and they are printing this to the console. So client who wants food, who wants the not, okay. Let's see. Client code abstract handler. Okay. So result handler that handle food, and it will give you the text here. And yeah, if somebody handled the food, you have the result, and you write the result to the console. Otherwise, you just write a message that food was left untouched, so no handler handled the food. And yeah, you basically do it like this. You have to choose what's the order, basically. So you create your handlers: monkey, squirrel, dog, and so on. And you then do like monkey set next squirrel set next dog. So yeah, this is like they wanted some syntactic sugar, or just some elegance here, so that you don't write like monkey dot set next squirrel, and then squirrel dot set next dog. They are basically, when you do set next, they are also returning squirrel, right? It's just a thing that, yeah, returning the handler from here will let us link handlers in a convenient way like this. Yeah, they didn't need to do this for like educational purposes, but it's good like in practice to have, yeah, because you might have, and it's also like visually, it makes sense visually, because it's intuitive. Like you say, okay, sorry, if monkey doesn't handle it, then the squirrel might handle it, and if squirrel doesn't handle it, then dog might handle it, right? And let's see. Client code monkey. So basically, yeah, you have your handler chain here, and the client code executes this thing. So for nut, it executes this, then for banana executes this, and then for coffee executes this. And each time it just goes to the first handler and says it handle the food, right? And you get the result, right? And first for the nut, it will go here, and then the monkey handler say, okay, this is not banana, then base handle this thing, and base says, okay, is there a next handler? Yes, we have the squirrel as a next handler. Then return whatever the squirrel handler returns, right? And the squirrel handler returns says, okay, this is a nut, then I return this thing, and so on and so forth. So squirrel, then the banana goes directly here, and the monkey handler immediately returns it. Then cup of coffee goes to the monkey doesn't see it, goes to the next one, which is a squirrel, goes to the next one, which is a dog, goes to the base, and the base says, in the dog, the base says, is there a next handler? There's none, because after the dog there's no handler, and it returns null. And basically you'll see like cup of coffee was left untouched. Yeah. So this is an important thing. So you might have it like in games, I don't know, yeah, like creativity is not at its highest at this hour of day. Good, let's go next. There are just 2 more or 3 more. Facade pattern. Oh, okay, this is very simple. So imagine like you have a lot of components, like we have let's see, maybe we have an example here. So let's read. So a simplified interface to a complex subsystem. It decouples the subsystem from its clients and other subsystems, promoting portability. Yeah, so a minimal library system interface that hides the complexity of the underlying system operations from the library patterns. Yeah, maybe that's a spelling error. So basically, imagine like you have an object with a lot of functionality, a lot of functions, and or even you have a bunch of objects. Like you have in the case of a coffee, well, not a coffee machine. Let's say you have a lot of objects, and you have all of those objects have some functionalities, but you only need, like, you can create lots of things with them and execute lots of things with them, but you only need a very specific subset of those functionalities. And in that case, you create a specific class for that specific role, and you pass it all of these dependencies, like, I don't know, coffee maker, plane ticket, buyer, weather watcher, and so on, right? And this facade class will only know to do a few things, but more high level things like plan meeting, right? And it's kind of that thing with I don't remember, like composition, like the facade patterns in a way like the composition over inheritance thing. Like you have a thing that's a facade and you don't care what's behind, and you just want the simplified user experience or the simplified developer experience. Yeah. Okay. Good. That's facade pattern. And builder pattern separates the construction of a complex object from its representation, allowing the same construction process to create different variants. Example, a document converter that can produce different formats of documents from data using the same construction process. I don't really think it's a good example. I don't remember what I was thinking, but yeah, the builder pattern actually is a really it's a popular thing. So instead of having like, or you know, class, yeah, let's say player, and you have like I don't know, icon. Let's just assume the icon is like an index in a big list of files. And let's also like say, I don't know, is there anything we can grab from here now? Just like you have like an interface for the attack algorithm, right? And let's create the constructor as well, right? So instead of doing this, new player, and pass all of the things here, icon, whatever, blah, blah, blah. Maybe you want to have like a base thing where it has all of these things like this, and you have like a builder, right? And what you can also do, like have this get or private set. I think it will work the way I want it. And you do something like new player builder, and you do it with yeah, for example, you set attack algo, right? Or you actually do it like this with attack algo, right? And this refers to the instance of this class. So basically you can return itself. Icon, no. So because these are private, I'm using this convention, right, with an underscore. So what we're doing here, so we're creating a builder class, which creates a player for us. But the cool thing is, if you create a builder, you then can create more players with it. But it's also more, I mean, it's just another way of doing the same thing. Okay, player.builder with attack algo, and we just provide the attack algo here. We don't have like an implementation for it, like a class who implements this thing, and there's no function here as well, but just you know, we just null, let's say. And then with icon, and you see we can change these things here because we return the builder itself, right? So we do with attack algo, with icon, and so on. With icon, I don't know, 0, and this is our builder, right? And then we press, we call builder.build. Oh yeah, we don't have one. New player. And you can also do this thing, I think. Icon, algo. And let's say the name will be always the same for, yeah, let's say. And text, texture, not text. This is like the type, and this is like the name of the field, and it's okay. You can have it like this. It's all right. Texture equals no, I don't know, just nothing. Yeah, and you can do it like this. So you create it like this, and you can assign things. So you see that we set the algorithm, and then you set the icon, the integer icon. And when you build, you set these things here, and I don't know, these things you can also like have them here, and create two functions like this. But let's say, for example, maybe you want to create, I don't know, just you want to create players with the same name or whatever, right? You do builder.build. Then you have your player, right? And you can also do it like this. You can player.build with algo, with icon, and you can directly build. And you see it's more, and you'll see like when you will work on bigger projects, this thing really helps because it's easier to see, right? And you have a player there, right? But also like if you want to create more players with it, you can do it like this, and you can then change. You can maybe want to change only the icon with icon 44. I don't know, right? Yeah, and now you build again. You get player with icon 44, right? So you have like the same things as here with only icon changed, and you build it again. And this is cool because if you wanted, if you needed, if you just would have created the player with the new, you'd basically you needed to do this and this, right? And you would change just the icon here to 44, and then again this if you want like a third player, right? But now you have like a builder, and it's similar to the factory pattern, right? But it's a bit different with these things. Like you see a lot of these things where with whatever, and the builder returns itself. So you can chain these things, right? Instead of writing a builder set algo, then builder set icon, builder set whatever. Good. Let's see, I think we have like 2 more things. Oh, this is 1 more thing just. Good. So event bus allows different objects to talk to each other via the publication and subscription of 2 events, decoupling event senders from receivers. An event bus is used to notify different parts of the UI about new message received without direct coupling between the components. And this is a thing that can go really wrong if you overuse it. But generally, you have something very similar to this weather, if we still have it here. Yeah, so the way it works, you basically subscribe functions to it. So you have like an event bus. Well, it's a bit more code to write. You have to find an event bus. I'll find an event bus now. Yeah, it's very similar to the observer pattern. Very similar. Yeah, it's similar to this thing. So you have like a component in your of project. So let's say like you have a game with I don't know, a football game, and you want to know when a certain I don't know, when a goal, so when somebody scores a goal, and this microservice, for example, is interested in that goal, in that event, and kind of it's when you have an event bus in your game, you kind of have this tendency to use it for everything, and you just have to really be careful. This is really important for you to understand. It's very important to not rely on events that are ordered, or to use the event bus to publish and subscribe to events that are order sensitive. So if your game's logic needs to follow a certain some steps, so certain steps, you shouldn't use the event bus like, okay, I'm waiting for like I'm subscribing to the loading screen completed event so that I can start the game, and somebody subscribed to game started event so that some sound will happen and some network message to be delivered and so on. No, that thing has to be explicitly, so you have to write your logic somewhere in code, or even there are some visual things like, I don't remember how it's called in Unity, but it was a nice visual logic thing. But just even if you don't have that, you just write in code. Like it's with states, like we talked about the state pattern, right? That's a very good candidate for this. But yeah, event bus is more of a so try to not overuse it, but it's very good for things that are more asynchronous. So like UI updating. So when you want to update a health bar on UI, that health bar can subscribe to health changed event, for example, for the player. So let's do it. I mean, it's really, this is like the last pattern, and but it's really important. So we have like an event bus. Okay, and you have like subscribe to this event type T. Yeah, this goes into a bit into templates and so on. But basically, let's say, let's do some templates. So basically, you have this thing like, how would you use templates? Oh, list. So you see here, you have somewhere here, you have the like the list. Yeah, and this is a shortcut. If you write it on here, you can write this shortcut here. But if you write like var here, you have to write it like this, right? So you have to specify it somewhere so it can know what it is. So you see, list is a template class. I mean, that's what it's called in C, in C++. This is a generic class because a list can be of integers, of strings. It can be of players, whatever. It can be of lists of players and so on, right? So the way it works is it just has an array behind the scenes. That's all. But it's called like T because it doesn't know what you will pass here. So generics are like parameters for the classes themselves, not for the functions, right? So this is like a parameter for a function. But here, like if you create a player T, like you created a generic player, right? And then you can have fields of type T, and you don't know what types there are, right? And that's how what I've used here, basically. And action is a special thing which basically you can store a function. So let's go, for example, build, right? Let's do this. So for example, action build action equals build. Let's see. Oh yeah, actually you need a function for this because yeah, let's do like some function. So you basically store the function. You see that we didn't call the function actually, but we referenced it, and we basically store a pointer to this function in this thing, and now we can just call it, and we call the function, right? And what this is useful is that you can pass this function to another function so it can call it, right? It might seem a bit confusing if you're a beginner, but just imagine that this is like a recipe, like, you know, a recipe for food online. So it's like you get the recipe, you write it on a piece of paper, and you give it to someone. It's exactly the same thing. So it's like you're giving a recipe to a recipe, right? So you have like a recipe for a pizza, but you also have the recipe for a sauce, right? Or for the topping, right? So you like have a recipe in a recipe. It's like the best thing I can come up with now. Yeah, and that's how functions work. So you basically can for a number, for an integer, for example, you store it in a variable, but for a function, you store it in an action variable, right? And what you can also do, you see here, this is a function that returns a value. You have to write it like this. Because this function returns a player, we have to specify, and these things are just the same thing, action and func. A func is just an action that returns something, right? And it's this is the variable type that stores your build function. And now you can do like, see? So you kind of call this function indirectly, or you can pass it to someone or to another function and so on and so forth. And that's generics for you and function. And this is our subscriber. So our event bus subscribes to an event type, right? And it calls then the subscriber with that an instance of that event, whenever someone fires that event, right? So let's make it even simpler. So event, actually, it's a keyword, Eve, right? And yeah, so subscriber subscribes, and you have a list. Okay, this is just an example for me. And the way it works, you have like a list, dictionary, type to action. I don't really remember. I think it's action object, something like subs. And you basically do get the type of this T is, and then you do subs. Yeah, it's actually a list. Yeah. Yeah, it might be confusing. So basically what you have a dictionary, and of course we didn't talk about dictionaries, so if you're a beginner, I'm sorry. But basically a dictionary is like a map, if you, or a hash map if you used other programming languages, or it's basically mapping a key to a value, right? So a simple dictionary would be like you have players, let's say, a simple example, and for each player you have I don't know, last attacked player, right? And you have it like this. And the way it works, you just set, okay, when you have A and B, and player A attacks player B, and then you just say A equals B. So you basically associate B to A, right? And when, I don't know, player A attacks now player C, you associate player C to player A, right? And another way to visualize them is like, I think this way. Well, let's put it integers, int. 1 is associated with 2, and I don't really remember how to write it here. But it's something like this anyway, right? Or I don't know. Let's say you kind of want to associate like num to even. is it even? So 1 is even, false. 2 is even, true. Very stupid example, but so you can get the idea, right? So basically, it's an associating thing, right? You have a key. This is the key, and this is the value, right? So 1 has the value false. 2 has the value true because it's even. 5 is the value false, and so on and so forth. And the way event bus works, so we associate a type to a list of subscriber to that type. And by the type, we mean the type of this parameter, which will be the event itself. So for example, we have fire event, and it might not even have any parameters, right? Or maybe we have like collision event. And okay, let's create a constructor. I don't know, game object collided. So basically the object who collided, right? And basically when you subscribe with a function where you can call this subscriber. This when that event fires, basically all of the subscribers to that event are notified. And when you do fire, what you do basically you go like if subs try get value. This is the nice syntax. Type of t. Yeah, this is like a lot of to unwrap here, but basically what it means, like, okay, if try to get the value of the type of this event, right? And if there are subscribers to this event, this will return true, the whole call, right? And this is a thing where it automatically creates a variable for you inside this. That's why it's called out var subs. And basically it will be of type this list action, right? And you basically do for each sub in subs. You basically do it like this. Sub if, right? So you pass it the event, which will be an either fire event or collision event. We don't care, right? Because these are a list of actions with an object type, and we have to put the object type here, not the t, because we can't know what type will there be here. And it works fine. It works really well, right? Otherwise we'd have, I mean, you know, you really cannot do it. You just have to put the object, right? So that like the most generic type of object in C#. 1 second. Okay. Stream is still going. Good. So this is how we do fire, and when we subscribe, we basically, what do? We do this again. We see, okay, do we already have a list of this event type? So if we do have, actually, if we don't have, we create a list. New list of actions. New list of, yeah, actions, which is empty. Yeah, and if we don't have it, then we create it and we add it. Subs at this type. So for this type, we associate this list that we have just created, right? And now whether this list was already here or not, let's see. No, I like it like this. Whether this list was present or not, here we are safe to use it, right? We are safe to use it. And we basically subs add subscriber. Yeah, I will have to do some fireworks here to make it work. But yeah, this is it basically. So if there's not a list already of subscribers for this type, we create one and we add it. We associate with this type. If there is one already, then it will just send it. It will just return it here out subs, and it will not enter here. But either way, the subs is now assigned, and we can just add the subscriber to it. And there's this thing here where we cannot convert from action T to action object, but it's very easy to fix. We basically do a hack. Let's see. So I have to remember how did I do this, because it doesn't allow you to add an action of to add an action where the T is specified to a list of action of type objects, right? But I have to get creative and or remember how I have done it before. So basically, because it's of type object, we'll receive. So this is what's called the lambda function. So what the lambda function is an intermediary. So basically this thing. This is a lambda function. So it's like as if we are doing action equals, I don't know, some function, right? Some function. But instead of doing that, and some function does, I don't know, something. Instead of doing that, we do directly a equals the list of parameters, which are none, and we do this thing directly, right? Bam. So this is our, and then we just can call action, like I said before, right? We call the action, then this thing happens. But we do it directly here. So what we're doing, so subs is expecting an action with an object parameter, basically a function that takes an object, and then we add this thing here, so the object, and then we call this thing here subscriber that object as t. Or actually it doesn't work, we have to do it like this. So we cast the object. So the object is, you see, it's an object, so we don't know its type at this moment here when it's fired, but we know its type because we are here and it cannot be other type other than t, right? So it's like a roundabout way of doing it. So subscriber, we cast the object back to t because we know it's a t, and now it works, right? And let's see, you have fire and you have subscribe, right? I mean, let's say like first you have fire, then subscribe. It's kind of, it's a good to, it's good. It's a good idea to place your methods chronologically. Yeah, good. And then you have the event bus, right? And let's say, I don't know, let's create. Let's use it. Right? Event bus example. So let's say we have a function who wants to respond to the fire event. On fire. Then we have a function, or it can be another class or whatever, right? Responds to the collision event. On fire, on collision. And I mean, someone creates the event bus for us and gives it here, but let's keep it simple. We just create it here. And we subscribe to our events here. So event bus, subscribe to the fire event, and subscribe this function of ours on fire, right? Bam. Then let's also subscribe to the collision event, and we'll subscribe this function, and we've subscribed, right? And then later somewhere in this in your game, maybe like in a very complete level by a different class, like everywhere, right? Somebody has a reference to this event bus. That's what I was saying, and I mean you can create it. Let's create make it a singleton, right? Public static. It's not a really great idea always, because you would want to test this at some point, and you'd have to do some fireworks here to make it work completely. And you can create it even like this. So if you never change it, just make it mark it as read only. And if you want to be like perfectionist, just prevent anyone from creating an event bus, right? Because you'll only be creating it here, right? Then you go do like if bus equals, right? And now you can create it everywhere in your scene, in your game, right? You can access it through this thing, like here, and then you can like access it here if you want, and so on. Good. And then let's say somewhere else, you then do event bus. Let's actually like simulate like you don't know this thing here, so and you are using the instance directly. Fire, new fire event, and that's it. And everyone who subscribed, like you have maybe 100 subscribers or whatever, right? Will like we have a UI element on the screen or whatever, right? And they will be notified. And then let's say you have also the collision event, and the collision event needs where is it? Public read only. Yeah, it needs a generate constructor. Right, so new collision event, and you have like I don't know, you get your collider from somewhere, and you create the event which has a parameter and so on, and then you fire this event, and then this function will get called, and yeah, it will be called over and over again, right? Good, and that's your event bus. That's your event bus. Let me just paste it here. I'm pretty sure it will be useful for whoever sees this in the future. Oh, okay, I cannot paste it here. All right, well, you're lost. Just ChatGPT with OCR, right? Just ask it to parse the code for you, or actually it will create you this thing. Good, man, good. Dependency injection. A class, I mean, this is the last slide, and it's just an overview. A class receives what it needs from an external source rather than looking for them itself. And yeah, like I said, if you remember, the poor man's dependency injection is that thing where you, like the default thing since the beginning of programming time, where you pass dependencies on the object's constructor. So yeah, that's the simplest form of dependency injection, but there are frameworks and stuff that makes it easier for you for bigger projects. Don't even think about it for just smaller projects like a Tetris game or something like that. Yeah, modularity, loose coupling between classes. So that means that fewer and fewer classes know about each other. Because there's like a higher manager which knows what class instance to send to whom and so on and so forth, right? And they don't care about the instances themselves, don't really care where the stuff is coming from. And you can, yeah, testability. You can test things much easier this way, much easier, because maybe you have like a network service that connects to your database, gives you like the list of your users, and you have 100 users and just want to do some tests, but you don't want to change stuff on your database so that you won't delete stuff, even if you're like on a development environment where you are allowed to mess with things. But let's say like you want like a wrapper on your database, like you want just to have some hard-coded 100 or 10 users, right? And you want to always have the same things, and you want to be able to modify them without issues. And with dependency injection, you can basically just inject, which is called a mock. This is like a keyword in testing, in test-driven development. And you're basically injecting a fake database, right? And just imagine there are a lot of components in a game or in a project, right? You have like maybe 50 components, right? And you might want to mock all of them at once, right? And that's what dependency injection does. It makes those components not care about, or not care about where they came from, or where exactly, more specifically, where their dependencies come from, right? They are just supposing that, okay, whether I'm in a test environment or in a real environment, I'm doing the same thing, and I'm just communicating with my dependencies and giving them work to do, right? And flexibility is the process of swapping out component implementations. Yeah, this is another thing as well, but it's not that it doesn't happen that often as other like coding purists say it. But yeah, it can happen. Like I don't know, you have like a physics engine, but it's not applicable to Unity. Let's say like it's yeah, not Unity, another thing. You have like a physics engine, and you have some functions that will call on it, but you want it to be easy swappable, and just dependency injection works the same way. But this is not really about dependency injection. This is just a general thing, having like this flexibility. Dependency injection mostly talks or is about systems that automatically give you the dependencies that you need, right? So as I said about the coffee machine, you won't pass those three dependencies in the constructor. You just declare that you need them, and someone magically gives them to you, right? So it's less code, right, for you. And later we'll explore DY solution for Unity, dependency injection. Congrats, and now you're a good programmer, possibly. And here's also a meme for you. Yeah, so the CPU no longer overheats when you hold down spacebar. Changes in version 10.17. Comments. Long-time user 4 writes, this update broke my workflow. My control key is hard to reach, so I hold spacebar instead, and I configured Emacs to interpret a rapid temperature rise as control. So the control key. And admin writes, that's horrifying. Long-time user 4 writes, look, my setup works for me. Just add an option to re-enable spacebar hitting. Yeah, and this is like an exaggeration of a lot of things that happen programming. And see you tomorrow. This was a really long one, man. Yeah, just I hope you enjoyed it. So I'm pretty sure not too many people survived this one. So you would have to. Well, I have 5 likes. Wow. Yeah. So yeah, just rewatch this 1 or 2 times, and just you can add 5 years of experience on your resume. See you tomorrow.